Why Java is not a purely object-oriented language? Well, this question may be, especially asked for a fresher in the Java interview. Alright, and if you are a fresher, then make sure that you have an answer for this question. Well, let's understand why Java is not a purely object-oriented programming language in this video. Well, look at here, these are the 7 qualities. Well, whenever we say a programming language is a purely object-oriented programming language, then that programming language should satisfy these 7 qualities. Alright, the 7 qualities like encapsulation or data hiding, inheritance, polymorphism, abstraction, all the predefined data types are objects in that programming language, and all the user-defined types are objects in that programming language, and all the operations or methods that perform the objects must be only through methods exposed at the objects. Well, these are the 7 qualities the programming language should satisfy in order to call that programming language as a purely object-oriented programming language. Well, let's compare these 7 qualities with Java programming language, and let's understand why Java is not a purely object-oriented language. Well, you can see here among these 7 qualities, the 5th one and 7th one. Well, in Java, we have 8 primitive data types, right? Int, char, long, double, float, short, right? So these 8 primitive data types are not objects in Java, okay? And we can call these primitive data types without using objects in Java. Alright, that's the reason. This is the first reason why Java is not a pure object-oriented programming language. Okay, and 7th, you can see the quality. All operations performed on objects must be only through methods exposed at the objects. Well, in Java, we typically create a class and we define the instance variables and methods. And then we create an object of the class and then we call the instance variable and methods using object, right? But again, in a Java, you can see here we have static variables and static methods. In Java, we can call static variables and static methods without using object, right? So that's the reason. This is the second reason why Java is not an object-oriented programming language, because a pure object-oriented programming language should only access all the methods or variables through objects only. Okay, but in Java it is possible that we can access static variables and static methods without using objects. Alright, great. Well, let me demonstrate these reasons with an example so that you will understand better. Well, here you can see we have a class, within a class main method, and within a main method I have declared and initialized these primitive data types like integer, byte, short, long, double, float, boolean, char. So these are the 8 primitive data types in Java, and these are not objects, right? And we can access these primitive data types directly. Okay, we are not using objects to access these primitive data types, right? That's the reason. This is the first reason why Java is not object-oriented programming language. Well, if I run this program, it should work properly. There we go. This is the output of this program. You might be wondering, we have wrapper classes in Java, right? Correspond to each primitive type. So by using wrapper classes, can we make Java as a pure object-oriented programming language? Well, no, we cannot use wrapper classes to make a Java as a pure object-oriented programming language, because wrapper classes under the hood uses primitive types only. For example, look at here, this is a code snippet. Let me uncomment it, and you can see integer is a wrapper class for int primitive data type. And if you can see the description of this integer class over here, integer class wraps a value of primitive type int in an object. Well, this class, wrapper class, is just a wrapper on top of primitive type int. Okay, it does not replace the object. It internally uses primitive type only. For example, if you calculate these two numbers, then behind the scene, Java internally uses primitive type int to calculate these values. Okay, so there is a concept like in Java, boxing and unboxing, right? So Java internally uses primitive types to perform operation, right? It means that you cannot use wrapper class to make a Java as a pure object-oriented programming language, because under the hood, Java uses primitive type to perform the operation on primitive data types. Alright, so this is the first reason, that is in Java we have 8 primitive data types and these are not the objects. Okay, so this is the first reason why Java is not a pure object oriented programming language. And second reason is we have static variables and static methods in Java, right? And we can access them using without object. For instance, well, look at here, I have created one static variable message and I can access this static variable without using object. So look at here, this is the system.out.println and directly I am accessing static variable message without using any object. And again you can see the static method, and this static method I am going to access here without using object. So it means that in Java we can access static variables and static methods without using objects. So this is the second reason why Java is not a pure object oriented programming language. If I run this program, it should work. There we go. Alright, so these are the two major reasons why Java is not a fully object oriented programming language. Alright, so in the interview, in order to answer this question, make sure that you will provide this kind of explanation. Alright, I hope you understood why Java is not a fully object oriented programming language, and I have demonstrated with an example so that I believe that you understood why Java is not a pure object oriented programming language. Alright, great. Hey there everyone, Ramesh here. In this video we are going to talk about what is JDK, JRE and JVM. So this is a very important topic, especially for Java beginners, and Java beginners may get a question in interviews like what is JDK, JRE and JVM and what is difference between them. Well, in this video I am going to explain you what exactly is JDK, JRE and JVM and why we need to use JDK, JRE and JVM. And JDK, JRE, JVM are very important concepts in Java programming language. As a Java beginner, you need to understand what is JDK, JRE and JVM. Alright guys. So let's first understand what is JDK, JRE and JVM, and a bit later we will deep dive into the Java installation and you will see what exactly JDK and JRE contains. Alright guys. So first let us talk about JDK. JDK stands for Java Development Kit, and JDK contains a JRE along with that compiler, debugger, javadoc and key tool. Alright, so just remember JDK is a software development kit which we can use to develop and run Java programs or Java applications, and JDK contains a JRE plus compiler, debugger, javadoc and key tool. Alright guys, now let's talk about JRE. JRE stands for Java Runtime Environment, and we use JRE to run Java programs or Java applications. Well, look at here, JRE contains JVM along with that class libraries. So basically JRE is an implementation of JVM and we use JRE to run Java programs. So if you have already developed Java applications or Java programs, and if you want to run Java programs or Java applications, then JRE is sufficient. Alright, so if you want to run Java programs, then you can use JRE. Alright, so just remember JDK we use to develop and run Java programs because JDK contains a JRE plus compiler, debugger, javadoc and key tool, and JRE we use only to run Java programs or Java application because it don't have a compiler, debugger or javadoc key tool to develop Java programs or Java applications. So whenever you want to run only Java programs, then you can use JRE. So if you want to develop and run Java programs, then you have to use JDK. Now let's talk about JVM. JVM is in the heart of Java programming language. When we execute a Java program, JVM is responsible for converting a byte code into machine specific code. Okay, so JVM is also platform dependent and provides core Java functions such as memory management, garbage collection, security, etc. Alright, we can also customize the JVM as per our requirement. Like we can customize JVM, like we can allocate minimum and maximum memory to JVM. So JVM is called abstract virtual machine because It provides an interface that does not depend on underlying operating system and machine hardware. So just remember, we use Java Virtual Machine to translate a byte code into a machine specific code, and JVM is platform dependent. To understand more about JVM, let's move to the second slide. So look at here are the steps to run any Java program. Okay, so let's say we create a file with .java extension and we write a Java program into it. So we use JDK to develop Java programs or Java applications, and we use a Java compiler to compile Java program into Java bytecode. So JDK has a compiler, so we can use a Java compiler to compile Java program into Java bytecode. So we use JDK to develop a Java program and to compile Java program. Alright, so once we have a Java bytecode in .class file, then we need a JVM to translate Java bytecode into machine specific code. Alright, so we use JVM to translate Java bytecode into machine specific code, and this machine specific code is a setup instruction that automatically executes via CPU and which will again produces the output. Now let's quickly explore Java installation and what JDK and JRE exactly contains. Alright guys, so when we install Java, by default Java folder is created inside program files. So look at here, Java folder has created inside program files, and if you open Java folder, you can see two folders, JDK and JRE. So I have already installed Java 8, hence we can see here JDK 1.8, JRE 1.8. so when we install Java, along with JDK we will also get a JRE, and JDK we use to develop and run Java programs or Java applications, but JRE we use only to run Java programs or Java applications. Alright guys, now let's explore what is there inside JDK. So look at here, JDK again contains internally a JRE. Okay, along with JRE it contains a debugger, compiler, and tool, key tool. Let me quickly see here, key tool and also debugger. Alright, so JDK contains JRE, along with that it contains a compiler, key tool, debugger. Now I have shown you what JDK contains. Now you will be able to remember what JDK is and what JDK contains. Alright, just remember, Java Development Kit is a software development kit which we require to develop and run Java programs, and JDK contains JRE plus compiler, debugger, key tool, and Java doc. Okay, now let's deep dive into the JRE. So let's open JRE folder. So JRE basically contains a JVM implementation plus some of the class libraries which requires to run Java programs or Java applications. So these are the class libraries which are basically required to run Java programs. Alright, so now you can able to remember what JRE is. So JRE stands for Java Runtime Environment, and which we use to run Java programs or Java applications, and it contains JVM implementation plus class libraries to run Java programs. Now we have the basic understanding of JDK, JVM, and JRE. Let's look into the difference between them. JDK is for development purpose, and whereas JRE is for running Java programs or Java applications. JDK and JRE both contains JVM so that we can run our Java programs or Java applications. JVM is the heart of Java programming language and provides a platform independence. Alright guys, I hope you understood what is JDK, JRE, and JVM, and also you understood the difference between them. In this video we are going to discuss few frequently asked Java entry questions on main method. Well, as we know that main method is the entry point for all the Java programs, or we can say the execution of any Java program starts from the main method, right? For instance, let's say I have a class and here I quickly create a main method, and main method is basically a standard, right? So in main method we have these signatures: public, static, void, and the name of the method is main, and then method argument array of string, right? Well, you can see this main method here. We have array of string, right? We have passed array of string, but we can also give var args. So this is called var args. It means variable arguments, right? Either you can provide array of strings or var args, okay, variable arguments. So this is the standard syntax, standard syntax for main method in Java. And main method is basically an entry point of all Java programs, or we can say every Java program execution starts from the main method. Well, you can see right here, these are the 8 important questions on main method that we are going to discuss in this video. Well, the first question is why the main method is public static. Well, first let's see why main method is static in Java. Well, main method is static in Java, so JVM can directly invoke it without instantiating the class's object. Well, as we know that whenever we call a main method, whenever we call a static method, we don't have to create an object of the class, isn't it? We can use a name of the class to call the static method. Well, as we know that main method is a static, so JVM can directly invoke static method, okay? And JVM no need to create object of the class, right? And basically the static methods will be loaded at the time of class loaded. So JVM basically loads the classes, right? So while loading the classes, JVM will also load the static methods, because static methods are class level, not to the instance, object level, isn't it? So let's say if main method is non-static, then JVM needs to create an instance of the class, and there would be ambiguity if constructor of that class takes an argument, right? For example, let's say this is the class, and this class has many constructors, parameterized constructors. Like this constructor take one argument, this constructor take two arguments, this constructor take array of strings, right? There could be any number of constructors in the class. And let's say JVM want to call the main method of this class, then JVM what it need to do is it need to create an object of the class, right? While creating an object, it should call the constructor. Then here you can see we have too many constructors in the class. While creating a class object, JVM which constructor need to call, right? There should be an ambiguity, right? Which constructor, which constructor, which parameter JVM need to pass. That is the ambiguity, right? That's why the main method made a static, so that JVM can call static main method directly. It no need to create an object of the class. I hope this clear to you. So in interview, make sure that you will give an example like this. Create a class, create a few parameterized constructor, and you can say like, while creating an instance of the class, JVM will call the constructor, and JVM will confuse like which constructor need to call, which what are the parameter need to pass, right? So this will arise an ambiguity. That's the reason main method made as a static, so that JVM will directly call it, isn't it? Now let's see why main method is a public. Well, as we know that anyone can access a method having public access specifier. So main method is a public in Java because it can be invoked by JVM. So if main method is not public in Java, then JVM won't able to call it, right? So if you make any method as a public, you can access that public method from anywhere. If you make it private or protected, then there would be a access restriction, right? That's why main method made as a public, so that JVM can call it from anywhere, isn't it? Your main method can be located in anywhere, anywhere in the project, so that JVM will able to call it. That's the reason main method has made a public, so that JVM can able to access it from the anywhere, isn't it? Let's take a look into the next question. Can we overload main method in Java? Yes, we can overload main method. A Java class can have any number of main methods, but to run that Java class, the class should have a main method with this exact signature, public static void main, and the method argument is array of strings, right? So yes, we can overload the main methods in Java. So there can be any number of main methods in Java class, but in order to run that Java class, your class should have main method with these signatures, right? For example, let me demonstrate this. Let's say I have a main method over here, and let's say I have sysout. I will just put a main here. Okay, and I will create one more main method with different signature over here. Let's say int, and I will make it as int. So now we have two overloaded main methods with different signatures. Let me overload another method. Let me call it as a long, array of long, and then here I will pass long. Okay, now I have three overloaded main methods. So in order to run this Java class, there should be a standard main method which has public static void and the method argument array of string or string varchar. So here we can replace varchar with array of string, isn't it? So let me run the program, and you can able to see only this will get print. Here you can see, because this is the standard main method that JVM will invoke, and other overloaded main methods JVM won't be able to access because the signature here is the different, right? The method argument is different. Now what we'll do, we'll see if I remove this standard main method and if I try to run this program, then JVM won't able to run this program because it won't able to find the main method, standard main method, right? Here you can see the error, main method not found in this class, correct? So that's why you can overload any number of main methods in the class, right? But in order to run this Java class, your Java class should have this standard main method with these signatures, public static void, and the method signature is array of strings, right? I hope this is clear to you. Well, let's take a look into the next question. Can we declare the main method as a private, protected, or default? Well, no. I mean, the main method must be public. You cannot define main method as a private or protected or default. So this is because main method accessible to JVM. So if you made a main method as a private or protected or default, then JVM won't able to call it, because the visibility or access should be restricted in case of private, protected, or default. All right, so let me demonstrate this with an example. So let me remove this. Now I have a main method in my class, and the main method is public. Now JVM can able to access this public main method, and here we go. The program should run properly. If I made this main method as a private, then JVM won't able to access because its scope is only related to this class. We cannot access private method from outside the class, isn't it? So if I run this program, then JVM won't able to access this method. You can see main method not found in the class. You will get this error. And let's say if I make this main method as protected, this also gives the same error, right? Here you can see. And if I remove protected, by default there is a no access modifier, then this will be the default method. So let me run the program, and there we go, right? So main method should be public so that JVM can able to easily access it, right? So let me make it public, and let me run the program, and this should work properly, right? It means that we cannot make main method as a private, protected, or no access modifier. I hope this is clear to you. Let's head over to the next question. Can we declare the main method as non-static? No. So if you make main method as a non-static, then again JVM have to create object of the class, and then JVM will need to call this non-static method using object, right? That's why main method must be declared as a static so that JVM can call the main method without instantiating its class. If you remove static from the main method signature, the compilation will success, but a program fails at runtime. So let's go and let's see. Here I have main method. If I remove static keyword from the method and if I run the program, it should give the error, right? Main method is not static in the class, because if I make non-static, if I make this main method non-static, then JVM have to create object of this class. And let's say if I have multiple constructors, especially parameterized constructor in this class, then there should be an ambiguity, right? JVM which constructor need to call, what are the parameters need to pass, right? So there should be an ambiguity. That's why we have to make main method as static so that JVM can able to access it directly, right? So I hope this is clear to you. Okay, we cannot make a main method as non-static. Let's head over to the next question. Can the main method take an argument other than string array? No, an argument of main method must be a string array, but from the introduction of var args, you can pass var args of the string type as an argument to the main method. Again, var args nothing but arrays. Let me demonstrate this with an example. So here you can see I have a class, within a class main method. So this is the standard main method, and you can see this is a string array, right? And we can replace string array with var args. Okay, you should put here 3 dots. So this is called var args. So this var args nothing but arrays only. Alright, so you can either make a main method with string array or var args. This is called variable arguments. Okay, both same. I mean var args nothing but arrays only, right? So you cannot pass any other arguments to the main method. You should have to pass string array or var args like this. Okay, I hope this is clear to you. Let's take a look into the next question. Can we run a Java class without main method? The answer is no. We cannot define a class or we cannot run a class without main method starting from Java 7. In the previous release, that is before Java 7, we have a static initializers as an alternative. But from Java 7 onwards, we cannot run a Java class without main method. Okay, so this is a perfect example for that. Well, let's next take a look into the next question. Can we make the main method as a final in Java? Well, yes, you can make the main method final. Here is the example. So let me demonstrate this with an example. Well, here you can see I have a main method, and let me make this main method as a final, and if I run this program, it should be able to work properly, right? So we can make this main method as final so that it cannot able to override in its subclass, right? So we cannot override the final methods in Java, right? So obviously we can make main method as a final so that it cannot be overridden in the subclasses. Okay, so we can make main method as a final. It is possible, right? So here I have demonstrated you with an example over here. Alright guys, these are the 8 very important questions on Java main method. So whenever you prepare for the Java interview, make sure that you will just take a look into these main method interview questions. And these questions especially ask for the freshers, right? So go ahead and check out this blog post. I will provide a link of this blog post in the video description below, so that whenever you will prepare for the interview, just take a look into this blog post and these 8 interview questions on main method. Hey guys, Ramesh here, back again with another video. In this video we will discuss Java array interview questions and answers for freshers. Well, in this video we will discuss few frequently asked Java interview questions on array topic. Okay, and I am going to recommend these interview questions especially for the freshers, because we are going to discuss very basic Java array interview questions in this video. Well, let's take a look into the first question. What is an array? An array is a data structure that defines an indexed collection of fixed number of homogeneous elements This means that all the elements in the array have the same data type and array starts from the index 0. Let me explain you what is an array with the example so that you will understand better. Let me switch to the IntelliJ IDEA over here. Here I have a main class. Within a main class I have a main method, and within this main method I am going to create an integer array over here. So look at here, this is an integer array with 10 elements, and as we know that array is a data structure, right? Because we are storing elements in an array, that's why array is a data structure. And array is index based because each element in the memory represents an index. For example, 10 stored in an index 0. Okay, 10 stored in an index 0 and 20 stored in index 1, 30 stored in index 2, like that. If you want to retrieve element 10 from the array, you can use index 0 because array starts from the index 0. Okay, let me write the comment over here. Array starts from index 0. Okay, and if we create an array using new keyword over here, we need to define the size. For example, let's say 10, and this 10 is fixed. So once we create an array with some size, we cannot change it later. Okay, once we create an array with some size, we cannot change the size of an array later. The size of the array should be fixed, right? Size of the array is fixed. Okay, and in an array we can store only the similar type of data. Similar type of data meaning, let's say if we create an integer array, we need to store only the integer numbers. We cannot store other data type values like string, okay, long. For example, let me demonstrate you. Let's say I have an integer array, and if I store 10, it is valid, 20 it is valid, and if I try to store some string over here, for example Ramesh, it will give you the compilation error because you can see the required type int, but we are providing string, right? It means that we can store only the similar type of data in the array. For example, if we create an integer array, we need to store only the integer numbers. If we create a string array, we only store the string values. For example, if I create one string array over here, string array, and if I try to store integer, it will give the compilation error. You can see required type is string, but we are providing integer. And if I store string over here, for example Ramesh, this is valid because we are storing string value in the string array, right? So array is we can store similar type of elements. Type meaning integer or string, long, double. Okay, so we can store similar type of elements in an array. So one more very important point is array can be a primitive type or reference type. For example, here you can see we are creating an array with primitive data type int, and here we are creating an array with a reference type string. It means that we can create an array using primitive data types as well as reference type. Reference type can be a built-in reference type or user defined reference type. For example, we can create a student class over here, let's say student, okay, and we can create an array of student class. So student classes already exist. Let me give some other class name here, book, and we can create a book array, right? For example, book array, and we can create an object of the array. We can define the size, right? So array can be a primitive data types or a reference type. Okay, and the main use of array is that we can store multiple values in a single variable, because here you can see we are storing 10, 20. These are the multiple values, right? We can store any number of, we can store three values, 4, 5, 6, so on. So instead of creating a separate variable, for example like this, int a equals to 10, okay, int b equals to 20, int c equals to 30. So instead of storing individual values in a separate variable like this, we can create an array and we can store multiple values in the array, right? So this is the main use of array, because we are storing multiple values in a single variable. So instead of storing each value in a individual variable, we can create an array and we can store multiple values, right? So this is the main use of an array. All right, so whenever you will answer to this question like what is an array, make sure that you will mention all these important points. All right, great. So let me recap the points. Array is a data structure, and we can store similar type of elements in an array, and array index starts from 0, and the size of the array is fixed, cannot be changed after the array has been created. And in Java, arrays are objects, so arrays can be primitive types or reference types. And the main use of array is to store multiple values in a single variable instead of declaring separate variables for each value. Okay, so let's take a look into the next question. What is the advantage and disadvantage of an array? Well, the main use of array is to store multiple values in a single variable instead of declaring separate variables for each value. For example, you can see here, the main use of array is to store multiple values in a single variable instead of declaring a separate variable for each value, right? So int a equal to 10, int b equal to 20, int c equal to 30. So here we are basically creating a separate variable to store a separate value, right? So instead of doing this, we can create an array, we can store multiple values, right? We can reduce a lot of lines of code here. Let's say I have a requirement to store 100 values. Then if I don't use array, then I need to create 100 individual variables and I need to store 100 values in 100 individual variables. So instead of creating 100 variables, what I can do, I can create an array, I can store 100 values in an array. In this way we can store 100 values in a single variable, isn't it? So this is the main use of array. Next advantage of array is that we can access any element randomly by using indexes provided by arrays. Well, as we know that array is index based, right? We can access elements from the array using indexes. For example, let's say I have array, integer array with these 6 elements, and I want to access 50 from the array. Then what I can do, simply let me put this out here, and I can use index over here. For example, as we know that array index start from 0, so 10, 0, 1, 2, 3, 4. So I can provide index 4 here, and I can get the 50 value from the integer array. Let me run the program, and you can see 50. And if I want to get 60 value from the integer array, then I can simply pass index 5. If I run the program, I will get a value 60 from an integer array. It means that array provides indexes a mechanism so that we can access value randomly from the array by using index. The next advantage of an array is that we can sort multiple elements of an array at the same time. As we know that we can store multiple elements in an array, so we can sort multiple elements of an array at the same time. And the main disadvantage of an array is that size limit. We can store the only fixed size of elements in the array. It does not grow its size at the runtime. So this is the main disadvantage of an array. Well, here you can see the example. Once we define the array with some size, let's say size 5, we cannot change this size at the runtime, and we can store only 5 elements in the array. If we try to store 6 or more than 6, then this will give you the index out of bound exception. And another disadvantage is that arrays are strongly typed. It means that all the elements in an array have the same data type. We cannot store different types of the data in an array. For example, if we create array of integer, we can store only integer values. if we create a string array, we can only store the string values. If we create a user defined class array, then we can store only the user defined class values or objects. We cannot store different data type values in the array, isn't it? So these are the two disadvantages or limitations. Well, let's take a look into the next question. What are the types of an array in Java? Well, there are two types of an array: single dimensional array and multi-dimensional array. A single dimensional array is a normal array where array contains sequential elements of the same type. For example, look at here, this is a integer array, right? And this integer array contains the sequential elements of the type integer. Okay, so just remember, single dimensional array is nothing but a normal array, and basically array contains a similar type of elements. Okay, and multiple dimensional array is nothing but array contains array of arrays. Okay, a multi-dimensional array in Java is an array of arrays. For example, two-dimensional array and three-dimensional array. So these are the example for multi-dimensional arrays. Well, two-dimensional array is an array of one-dimensional arrays, and three-dimensional array is an array of two-dimensional arrays. And look at here, this is example for two-dimensional array. So let me explain with example. Let me add to the IntelliJ IDEA over here, and look at here, this is the example for two-dimensional array. Okay, so if you can see here closely, this is the first array within a curly braces. So this is the first array, and within this array we can see one-dimensional arrays. Okay, so array of one-dimensional arrays. And if you want to access elements from the array, you can see this is the syntax. So just remember, multi-dimensional array is nothing but array of arrays, and two-dimensional array and three-dimensional array. So these are the examples for multi-dimensional array. Well, let's take a look into next question. Can you pass the negative number in array size? No, you cannot pass a negative number as an array size. Well, if you try to pass a negative number as array size, then you will not get any compile time error. Instead, you will get a runtime exception. For instance, you can see this piece of code over here. I have created an array and I have tried to pass a negative number, that is -5, and you can see there is no compilation error. But if you try to run this program, you will get a runtime exception. So look at here, negative array size exception. Alright, so this basically demonstrates that you cannot pass a negative number as an array size. You have to pass a positive number as an array size. Alright, I hope this is clear to you. Well, let's take a look into the next question. When array index out of bounds exception occurs. Well, if you have already worked on an array, then you might got this exception, right? So this exception is frequently occur when we work with an array. Alright. Well, this exception basically throw when we try to access an array with illegal index. Here illegal index meaning the index is either a negative or greater than or equal to the size of an array. Alright, so whenever we try to access an array element with an illegal index, then this exception typically occur. And illegal index meaning the index is a negative number or greater than or equal to the size of an array. For example, look at here the code snippet. We have a main class. Within a main class we have main method. Within a main method we have created an integer array with 5 elements. Here we are trying to access an array element with index 5, but the element with the array index 5 is not exist in this array because array starts with index 0, and this index 5 is equal to the size of an array. Alright, basically we are trying to access an array element with index 5 which is not exist in this integer array. That's why this program should throw the array index out of bounds exception. You can see the output of this program, and here you can see the exception message, index 5 out of bounds for length 5. Alright, so here basically we are trying to access an array element with index 5. The index 5 is equal to the size of an array. Alright, basically this is the illegal index. Well, next you can see one more example over here. Here we are trying to access an array element with a negative index. You can see -2. Alright, so this is the illegal index. In this case also This program throws array index out of bounds exception. You can see the output of this program. Alright, so whenever we try to access an array element with illegal index, then basically out of bounds exceptions occur. Well, the next question is difference between array and array list. Well, this one is a commonly asked interview question, guys. And here I have listed few important difference between array and array list. Well, the first important difference is array is static in nature. It means array is fixed length data structure. Once we create an array with some size, we cannot change its length later, right? On the other hand, array list is dynamic in nature. If we add elements to array list, it will automatically increase its size. Alright, so array list has default length like 10, and whenever we add elements beyond 10, it will internally increase its size automatically. Alright, so just remember, array is static in nature. It means fixed length data structure, and array list is dynamic in nature. Alright, array list internally grows its size automatically. Alright, next difference is an array can contain both primitive and object data types. On the other hand, array list does not contain primitive types. It only contains the object data types. Alright, so if you want to use primitive types in array list, then you can go ahead and use primitive wrapper classes. So we have wrapper classes correspond to each primitive data type, right? So array list does not contain primitive data types. So if you want to store primitive data types in array list, then go ahead and use wrapper classes. Okay, so this one is also an important difference. Next is Java provides add method to insert an element into array list. On the other hand, we have assignment operator in Java to store elements into an array. For example, look at here, array list has add method, so we can use add method to add element to the array list. On the other hand, look at here, assignment operator. So we can use assignment operator to store elements in an array. Okay, here we have created an array and we have stored 10, 20, 30 into an array using assignment operator over here. Alright, so this one is a basic difference between array and array list. So next is we cannot use generics along with an array, whereas array list allows you to use generics to ensure type safety. Alright, so array does not support generics, okay, and array list allows you to use generics to ensure type safety. You can see the example over here. We have created an array list object and look at here the generic. Alright, so we can use the generics with array list to ensure that type safety. Well, the next difference is we can get the size of an array list by using size method. On the other hand, we can get the array size using length variable. Well, you can see the example over here. So this is the program to find the length of the array list by using size method. Alright, so you can get the size of an array list by using size method. On the other hand, in case of array, you can use length variable to get the length of an array. So you can see here is the array of integers and you can get the length of this integer array by using length variable. Well, the next difference is the performance of an array and array list. Well, the performance of array and array list depends on the operation you are performing. For instance, resize method. Well, you can see the resize method internal implementation. Well, whenever array list reach its size, then resize method internally basically uses a temporary array to copy elements from old array to new array. So this will take some time to copy the elements from old array to new array, right? That's the reason the performance will slow down in case of resize operation. Alright, and in case of add or get operations, the array and array list performance is almost same because array list internally uses array to add and access the elements, right? That's the reason the performance wise add or get operation remains same for array as well as array list. Alright, great. So these are the few notable differences between array and array list. Try to explain each difference with an example. Alright, so next you can see the question, can you declare an array without array size? No, you cannot declare an array without array size. You can see you will get a compile time error. So this screenshot shows that you cannot declare an array without array size. Otherwise you can see the compile time error. array initializer expected. Alright, next question is, where does array store in JVM memory? Well, as we know that array is an object in Java, right? So all the objects in Java are stored in a heap memory. That's the reason array is also a object, so array should be stored in a heap memory in a JVM. Alright, as we know that array is an object in Java, so array is stored in a heap memory in the JVM. Well, the next question is, what is array store exception when this exception is thrown? Well, basically array store exception is a runtime exception. Alright, and the array must contain the same data type elements, otherwise you will get array store exception. Well, if you try to store a different type of the element in an array, then typically this exception occur. For example, look at here, employee array. Alright, and here we have provided a reference type as an object so that you can add different type of element to an employee array over here. And here we are trying to add string to employee array with index 0. In this case you will get array store exception because you are trying to store different type of element in the array, that is employee array. You can see once we run the program you will get array store exception over here. Alright, it means that whenever you try to add a different type of element into an array, then typically you will get this runtime exception, that is array store exception. Alright, well, the next question is, what is the difference between array store exception and array out of bounds exception? Well, already we have gone through these two exceptions, right? Here we can summarize the difference. Like, array store exception is thrown if you try to add an incompatible data type. For example, if you try to add integer object to string array, then you will get array store exception. So this is a runtime exception. Well, array out of bounds exception is thrown when an attempt is made to access an array with an illegal index. Well, here illegal index means the index can be either negative or greater than or equal to size of an array. Alright, if you try to access an array with illegal index, then you will get array out of bounds exception. Alright, well, next question is, what is an anonymous array in Java? Give an example. Well, we have seen like we have anonymous class, anonymous function in Java, right? Anonymous function meaning lambda expression. So lambda expression don't have a name, right? So similar to that, we can also define anonymous array. Alright, an array without any name is called anonymous array. Alright, and here you can see the code snippet. We have a main class. Within main class we have main method and we have sum method. So this sum method takes an integer array and then it will calculate the sum of this integer array. And here we are directly passing the integer array to the sum method, right? We are not giving a name to this array. Alright, so this is called anonymous array. Alright, anonymous array means array without any name is called anonymous array. Alright guys, these are the few important interview questions on array concept, and I highly recommend these questions especially for freshers. Alright, so if you are a fresher, then before attending any interview, so you can just go through these basic questions on array. Alright. Hey there everyone, Ramesh here, back again with another video. In this video we are going to discuss few important Java string interview questions. Well, it doesn't matter whether you are a fresher or experienced candidate, you will definitely get questions on Java string in the interviews. And in this video we are going to discuss few frequently asked interview questions on Java string handling. Alright, so if you are a fresher, then definitely you will get a very basic question, that is, what is string in Java? Well, try to describe about string in Java. I mean, just provide a few important points about string in Java. Okay, so here is the answer. String is a sequence of characters. In Java, strings are objects and string is basically immutable. So once you create a string object, you cannot change its content later. Okay, so string is a immutable. So once you create a string object, you cannot change it later. Alright, and from Java API point of view, string is a Java class which is defined in java.lang package, and string is not a primitive data type such as int, char, long, etc. Okay, so string is a class in Java which is defined in java.lang package. And if you can see here, this is a class diagram of string class. And just remember this class diagram, okay? Because string class implements various interfaces like comparable, char sequence, and serializable. So you may get a question like, what are the interfaces string class implements? So you can just memorize this class diagram and you can answer like string class implements comparable, char sequence, and serializable interfaces. Okay, great. So next question is, what are the different ways to create a string object? Well, basically there are two ways to create a string object. First way is by using string literal. Second way is by using new keyword. Well, using string literal is straightforward. You can just use double quote to create object of the string. And whenever you create a string object using string literal, then these string objects will be stored in string constant full. Okay, so string constant pool is nothing but a special memory in the heap area, and whatever the object that you create using string literal, those objects will be stored in a string constant full. So second way is using new keyword. So in Java generally we use a new keyword to create object of any classes, right? So similar to that, using new keyword we can create object of the string class like this. Okay, so basically there are two ways to create a string object. First way is using string literal, second way is using new keyword. And if you have pen and paper in your hand in interviews, make sure that you will just write examples and explain them. Okay, explain to the interviewer so that interviewer will be impressed to your answers. Okay, be practical, always try to give examples. Well, next question is, what do you mean by mutable and immutable objects? Well, in the first question, that is what is string in Java, you have included string is a immutable, right? Hence, you may get a cross question like, what do you mean by mutable and immutable objects? Well, here is the answer. Immutable objects are like constants. So once you create a immutable object, you cannot change it later. Okay, and whereas mutable objects are changeable. So once you create a mutable objects, you can perform modification or update operation on it. Okay, for example, string is a immutable in Java. So once you create string object, then you can't modify it, right? You can't change it. But even though you try to modify it, JVM will create a new object. Okay, it will keep the existing one and it will create a new one. All right. Whereas string builder or string buffer is a mutable in Java. So once you create an object of string builder or string buffer class, then you can perform modification operation on them. All right. So just remember, immutable objects are not changeable. So once you create a immutable object, you cannot change it later. But mutable objects are changeable. So once you create a mutable object, you can perform update operation or modification operation on that. Right? Great. The next question is, what is string constant full? Well, this is one of the frequently asked question. Okay, so string constant pool is a memory space in a heap memory specially allocated to store string objects created using string literal. Well, here you can see the diagram. Stack memory, heap memory. Well, in a stack memory all the reference variables are stored, and in a heap memory all the real objects are stored. And in a heap memory you can see string constant full. Well, string constant full is nothing but a special memory in the heap memory. All the string objects that are created using string literal are stored in a string constant full. Okay, so by looking into this diagram we can understand that string constant full is a special memory allocated in the heap memory, and all the string objects that are created using string literals are stored inside string constant full. Okay, and in string constant full there will be no two string objects having the same content. For example, look at here, string s1 equal to hello world, string s2 equal to hello world. So both of these objects are created using string literal. So whenever you create s1 string object, then hello world will be stored in a string constant full. If you try to create string object with the same content hello world, then JVM will first check whether the hello world is exist in the string constant full or not. If it is already exist, then JVM will basically point the reference to the hello world and it will return that reference. It won't store the same content again in the string constant full. Alright, I hope you got the idea. Alright, so string constant full basically contains a unique string objects. And look at here one more example, string s4 equal to new string. Well, here we have created a string object using new keyword. So whenever you create an object of class using new keyword, then that object will be stored inside a heap memory, right? So here you can see s4 is the reference variable which is pointing to greetings object, and greetings object is stored inside a heap memory, not in a string constant full, right? So basically string objects are stored in a special memory area known as string constant full. Alright, great. Next question is, does string is a thread shape in Java? Well, in order to answer this question, you should know what is thread shape first, right? So thread shape is nothing but if multiple threads are trying to access the method of the object at the same time, then there should not be any issue with that object. Then that object is treated as a thread shape, right? So thread shape is nothing but if multiple threads are trying to access the method of that object, and if there is no issue with that object, then that is called a thread shape object. Okay, so does string is a thread shape in Java? Yes, because strings are immutable in Java. It means strings are like a constant. So once you create string object, you cannot change its content later, right? Even though you try to modify or you try to change that object, then JVM will create a new object of that string. So strings are immutable or like a constant, hence it's a thread shape and can be safely used in a multi-threaded environment, right? So remember, strings are immutable or like a constant, so you can obviously use strings in a multi-threaded environment. Okay. Next question is difference between equal to operator and equals method in Java. Well, this is one of the common question that interview question that you will get in interviews. Okay, so in general both equals method and equal to operator in Java are used to compare objects to check equality, but there are some significant differences between them. Well, the main difference between equals method and equal to operator is that equals method is a method and equal to is a operator. Okay, and important difference between equals method and equal to operator is that we can use equal to operator for reference comparison and equals method for content comparison. Okay, it means that you can use equal to operator to check if both objects point to the same memory location, whereas equals method you can use to check whether both objects content is the same or not. Alright, so again try to explain this with an example. So here you can see here s1 equal to new hello world, s2 equal to new hello world. So here I have created an object of s1 and s2 using new keyword, and both objects are stored in a heap memory in different memory locations. And here I have just checked the condition. Here I have used equal to operator. Well, both the objects are stored in different memory location. That's why s1 equal to s2 returns a false, and content of the both objects s1 and s2 is same, that is hello hello. That's why equals of method returns true. Alright, so it means that you can use equal to operator to check whether the both objects are pointing to the same memory location. Okay, and if you want to check whether both objects content is same or not, then you can use equals method, right? And here I have created string objects using new keyword, but if you try to create these string objects using string literal, then you can see that s1 and s2 both objects should point to the same object in the string constant pool. In that case, both the reference are pointing to the same memory location, hence you will get s1 equal to s2 as a true. Okay, great. So whenever you try give answer to this question, try to write some piece of code in the paper and try to explain to the interviewer what is exact difference between equal to operator and equals method. Okay, so equal to operator is used to check the references, that is address comparison, and equals method for content comparison. Alright, so next question is difference between string and string builder. Well, this is again one of the frequently asked question. Okay, so string is a immutable in Java while string builder is a mutable in Java. It means that once we create a string object, we cannot change it later. But once we create object of the string builder class, then we can perform modification or we can change it later. That's why string builder is mutable in Java. Second difference is string is thread safe, whereas string builder is not a thread safe. It means that multiple threads can be able to access the method of the string object at the same time, whereas multiple threads cannot be access the method of the string builder object at the same time. It means that you can use a string in a multi-threaded environment safely, whereas string builder is not a thread safe, so you cannot use string builder in a multi-threaded environment. Well, the next difference is the performance of the string is slower than string builder in case of multiple concatenation operations. So this is because string is immutable in Java and concatenation of two string objects involves creating a new object. Right? So as we know, string is immutable in Java. So whenever we create object of the string class, we cannot change it later. But if we try to change, then JVM will create a new object, right? That's why if we do multiple concatenation operation using string, with respect to performance, it is costly. So whenever you have multiple concatenation operation, then try to use string builder. Okay, great. So next difference could be string class overrides equals method of object class. So you can compare the content of two strings by using equals method, whereas string builder class cannot override the equals method of object class. Okay, so this is just one more significant difference between string class and string builder class. So in a string, you can use equals method to compare the content of the two strings, whereas string builder class cannot override equals method of the object class. So you cannot compare two string builder objects using equals method. Right, so these are the few important differences between string and string builder. Well, the next question is difference between string and string buffer. Well, string is immutable whereas string buffer class is mutable. So string buffer is almost same as string builder, but the difference is string buffer is basically a thread safe. Okay, you can use string buffer in multi-threaded environment. Okay, and all the methods in string buffer are synchronized. Hence, you can use string buffer in a multi-threaded environment. Okay, so string class is basically immutable whereas string buffer class is mutable. It means that once you create a object of the string class, you cannot change it later. But whereas once you create object of string buffer class, you can change it later. That means string buffer is mutable. Okay, so next difference is string is slow and consumes more memory when you perform too many concatenation string operations, because every time it creates a new instance, right? So as we know, string is immutable, and whenever we create object of the string, we cannot change it later, but we try to update, or if you try to modify the string object, then JVM will create a new instance, right? On the other hand, string buffer is a fast and consumes less memory when you concatenate multiple strings. Okay, great. So one more significant difference is string class overrides the equals method of the object class. So you can compare the contents of two strings by using equals method, whereas string buffer class does not override equals method of object class. So one more significant difference is string class uses string constant full to store objects, whereas string buffer class uses heap memory to store its objects. Well, when we create a string object using string literal, then that object will be stored in a string constant pool, right? So in a string buffer, we don't have string literal concept. So whenever we create a string buffer object, we should use a new keyword, right? That means whenever you create object of the string buffer class, that should be stored in a heap memory. Okay, so this is one of the significant difference. Like whenever you create a string object using string literal, that will be stored in a string constant full, and whenever you create a string object using string buffer, then that would be stored in a heap memory. All right, great. Well, the next question is difference between string builder and string buffer classes. Well, I don't see much difference between these two classes. All right, because string builder and string buffer classes both are mutable. It means that whenever we create an object of these classes, we can perform modification operation on them, right? And here are the few significant differences. Like string builder is not a thread shape, whereas string buffer is a thread shape. It means that multiple threads can able to access the method of the string buffer object at the same time. Okay, that's the reason string buffer is a thread shape, and you can safely use string buffer in a multi-threaded environment. All right, and you can see all the methods in string buffer are synchronized. That means string buffer is a thread shape, and you can use string buffer in a multi-threaded environment. Next is string buffer is slower than string builder, because string buffer is a thread shape implementation, therefore string buffer is slower than string builder. So whenever you have concatenation operation, then go ahead and use string builder because it performs good, whereas string buffer a bit slower, because all the methods in string buffer are synchronized. So and it provides thread safety. That's the reason string buffer is a little bit slower than string builder. Alright, next question is which one you will prefer among equal to operator and equals method to compare two string objects. Well, this question is almost similar to difference between equal to operator and equals method. So interviewer will just ask question like this just to check your knowledge on equal to operator and equals method. So whenever you will get question like this, then you can answer like yes, I use equals method to compare two string objects, right? And also give a difference between equal to operator and equals. Well, the next question is what does the string intern method do? Well, intern method is pretty interesting. Okay, so intern method creates exact copy of the string object in the heap memory and stores it in the string constant full. Well, whenever you create a string object using new keyword, that object will be stored in a heap memory, and if you want to store that object again in the string constant full, then you can use intern method. Well, here you can see the code snippet. This code snippet demonstrates how you can use intern method. Well, here I have created object s1 using string literal and s2 object using new keyword. Okay, and here you can see the statement string s5 equal to s2 dot intern. So here s2 is created using new keyword. I want to move this object from heap memory to string constant full. In that case, I can use intern method over here. So whenever we create a string object using new keyword, then that object will be stored in a heap memory, right? And if you want to move that string object from heap memory to string constant full, then you can use intern method. So if you can see here this line of code s2 dot intern, so this s2 object will be stored in the string constant full, and you can see this statement s1 equal to s5. So the content of both the objects are same, abc. It means that whenever you use intern method, it should be stored in the string constant pool, and if this same object is already exist in the string constant pool, then JVM will basically return the reference. It won't again store the same content in the string constant pool. That's the reason here we are just checking both the references are pointing to the same object or not using equals operator. S1 equal to S5. Okay, so S5 here means S2 dot intern. So S2 object is created using new keyword, and we are using intern method to move this object from heap memory to string constant pool, and S1 is already there in a string constant pool. So if we compare S1 equal to S5, then the result should be true because both S1 and S5 references are pointing to the same object, that is ABC. Okay, So just remember what is the use of intern method. All right. The next question is, why string is popular hashmap key in Java? Well, as we know that string is a immutable, so its hash code is calculated at the time of creation and it does not need to calculate again, because string is immutable like a constant. So once we create a hash code for the string object, it remains same, so we don't need to create or calculate again and again, right? So this makes it great candidate for key in a map, and its processing is quite faster than other hash map key objects. So this is why string is mostly used object as a hash map keys. All right. So next question is, how many objects will be created in a following code and where they will be stored? So interviewer maybe will provide some piece of code and he will say like how many objects will created for this code and where exactly they will stored. Well, if you can see the first line here, string object is created using new keyword. It means that this object will be stored in a heap memory. And second statement, the string object is created using string literal. It means that the string object will be stored in a string constant full, right? And both objects are created separately because both the objects are stored in different memory spaces. So first object will be stored in heap memory, second object stored in a string constant full. That's the reason two string objects will be created, and S1 object will be stored in a heap memory and S2 object will be stored in a string constant full. So you may get another question like for example, here you can see interviewer will provide this line of code and he will say like how many objects are created for these 3 lines of code. So here you can see S1 equal to hello world, S2 equal to hello world, S5 equal to hello world. It means that here we are creating string objects using string literal. It means all these objects are stored in a string constant full, and JVM will check whether a same object is existing in string constant full or not. If it is already exist, then it will simply point this reference to that object. Alright, it means that only one object will be created for these 3 lines of code. Okay, so JVM will take care of storing the objects in the string constant full. It won't store duplicate string objects. Alright, so just remember, whenever you create a string object using string literal, then that object will be stored in string constant full, and you cannot store multiple string objects with the same content. Alright, if you try to store multiple objects with the same content, then JVM will basically return the reference. It won't store the same content again in the string constant pool. Alright, great. So these are the 14 commonly asked questions on Java string handling in the interviews. In previous video, we have discussed some important Java string interview questions and answers. Well, in this video, we are going to discuss few very important Java string tricky interview coding questions. Alright, we are going to discuss coding questions on Java string handling. Okay, and these very important coding questions have been asked in many interviews, guys. And you may get this kind of questions usually in a written test or in coding technical round. Alright, so basically you will get a question like you will get a code snippet and you need to find the output of this code snippet or a simple program, and you need to explain the program or the output. Or sometime in written test you will get this question or this code snippet and you will get multiple choice questions and you need to choose the output of this program. Okay, so basically we will see 10 coding questions on Java string handling in this video. Alright, so what I'm gonna do is I'm gonna execute these code snippets in IDE and I will explain you the output and what does this code snippet do. Okay, so first question is, what will be the output of this program? Well, let me quickly copy this program and let me execute in the IDE and let me explain you. Okay, in this way you will get a more idea. Well, here I have a class main method. Within a main method This is the code snippet. Well, if you look at the code snippet over here, string s1 equal to hello. Well, here we have created a string object using string literal. So whenever we create a string object using string literal, that string object will be stored in a string constant full. Well, I'm going to write a comment over here, string constant full. And here we have created an object of the string using new keyword, and this object will be stored in a heap memory. Okay, and again here s3 object we have created using string literal, so this will be stored in a string constant full. Okay, great. Now here, look at here, if condition s1 equal to s2. So before understanding this, we need to understand the difference between equal to operator and equals method. Okay, so equal to operator, basically it checks whether these two objects are, reference variables are pointing to the same object or not. Okay, so basically equal to operator is used to check the address location or the memory location, whether s1 and s2 both are pointing to the same memory location or not. Alright, so in this case s1 equal to s2, so both are pointing to different location, because s1 is created using string literal, which is there in string constant full. s2 is created using new keyword and it is there in a heap memory. So both are in different location, so both are pointed to a different location. That's why you can see the output is s1 and s2 not equal. Okay, let me run the program and look at here, s1 and s2 not equal, because s1 is pointing to the string object, that is hello, which is there in a string constant pool, and s2 object which is created using new keyword, which is present in a heap memory. So both objects have different memory location. That's why both objects are pointing to different memory location. Okay, so equal to operator is used to check whether the objects are pointing to the same memory location or not. Right, and look at here, second if condition s1 equal to s3. Well, s1 object is created using string literal and it is stored in a string constant pool. Similarly, s3 object is created using string literal and it is stored in a string constant pool. Well, basically JVM manages the string constant pool. Okay, so what JVM does, it will first check whether this hello object is stored in a string constant pool or not. If it is already present, then JVM will basically return the reference of that object. It means that JVM won't store two similar objects with similar content in the string constant pool. Alright, so look at the second condition over here, s1 equal to s3. So s1 object is created using string literal and which is stored in a string constant pool. s3 object is also created using string literal and which is again stored in a string constant pool. Well, basically string constant pool is managed by JVM. So JVM basically, it will check whether the string is present in string constant pool or not. Alright, if it is present, then JVM simply returns the reference, that is s3. Well, s1 is already stored in a string constant pool and s3 is again storing the same content, that is hello, in the string constant pool. But JVM will already check that hello is already present, right? That's why JVM, what it will do, it will just point this s3 to the hello. It won't store hello string again in the string constant pool. Only one occurrence of this object is kept inside string constant pool. Alright, it means that s1 and s3 both are pointing to the hello. And here we are using equal to operator to check the reference variables. Both are equal or both are pointing to the same object or not. So in this case, s1 and s3 are pointing to the same object. That's why you can see s1 and s3 are equal. Okay, here is the output, s1 and s3 are equal. Right, now let us see one more very important thing here is s1 equals to s2. Well, here look at here, we are using equals method. Okay, let me use equals method over here also, equals s3. Alright, so let me run the program first, and there we go. So look at here, we have created 3 string objects, right? s1 equal to hello, s2 equal to new string hello, s3 equal to string. Well, all of these 3 string objects have the same content, like hello, hello, hello. And if you can see the output, s1 and s2 equals, s1 and s3 equals. It means that equals method basically check the content of 2 objects. Well, here s1 equal to hello, s2 equal to new string hello. So hello, hello, it means the content is same, right? So equals basically checks whether both objects have the same content or not. If both objects have same content, then it will return the true, and then it will execute the if block. Otherwise it will execute else block. Correct? So let me just change this one. Okay, hello 1. Let me run the program. And look at here, s1 is not equal to s2. Okay, the content is different. That's why it is no went in a else block and is just printed s1 and s2 not equal. And again s1 s3, so content are different, right? That's why it went in the else block and it is printed s1 and s3 not equal. Okay, so in case of equals method, the memory location doesn't matter, right? The content matters. If content of both objects are same, then equals method returns true. Okay, so in Java, whenever you want to compare 2 string objects, then always use equals method. All right, great. So this kind of coding question you will get in interviews, and just try to understand the difference between equal to operator and equals method, so that whenever you will get this kind of questions, you will definitely answer it. Alright, great. So let's head over to the second question now. What will be the output of the below program? Well, let me quickly copy the snippet and paste it in the ID. And before understanding this, let me run the program and let's see the output first. Here we go. So basically what we are doing here is we have created object of the string using new keyword, and we have passed 5 as a string object. After that we have added a system.out.println, and then this is the value, right? So 1 plus 10. So one important thing is, whenever this expression get evaluated, then it always goes from left to right. Okay, so in this case 1 is a operand, 10 is a operand, s is a object, 1 is a operand. Okay, 10 is also operand. So this is basically called a operand. Okay, and here 1 and 10, so both are integer operands, right? That's why these 2 operands will get added. Okay, added means addition. 1 plus 10, 11. So you can look at here 11. After that we have a string object. It contains 5, and then 5 is concatenated with 11. Okay, and now it becomes 11 5. Okay, still 5 is a string, so it will again concatenate with 1. It becomes 1 1 5 1, and again string is concatenated with 1, so it will again concatenate with 10. It becomes 1 1 5 1 1 0. All right, I hope you understood the result of this expression. Okay, so it is evaluated from left to right, and whenever you will get a string in the expression, that will be concatenated. Okay, great. Let's head over to next question. Next question is, what will be the output of this program? So here you can see string equals to null, so string is declared as a null over here, and sys out and string dot value of. So let me quickly copy this snippet and paste it here. So what will be the output? Well, here we have declared string null, and we are calling value of method on null. It means that you might be wondering, like, this will throws the null pointer exception, right? Because we are calling value of method on null object, but this basically prints a 10. Let me run the program. Look at here the output. Why it is not thrown the null pointer exception? Well, the important point here is value of method. Well, value of method is basically a static method. Okay, so look at here, static member. Let me go inside this method, and here we go. Value of method is a static method. Well, in Java we can call a static method using class name, right? The object is not required to call the static method, isn't it? We can use a class name to call the static method, and here we are calling static method, so we can also use a class name to call the static method. If I run this program, it gives the same result, 10. Alright, you might get other similar questions, like instead of value of method you will get other static methods. Okay, so make sure that whenever you invoke static method on null reference, that will get successfully compiled, and that will produce the output. It won't throw the null pointer exception. Okay, great. Let's head over to the next question. Next question is, what will be the output of below program? Well, let me copy this code snippet again. Let me go inside IntelliJ IDEA and paste it here, and now let me run the program first, and then I will understand. It returned false. Okay, so let's understand the program code snippet now. String s1 equal to abc. Well, this is the string object which is created using string literal, and this is the string buffer class object, and s1 is passed to string buffer constructor, and here is system.out.println s1 equals to s2. Well, equals method is invoked on s1. s1 is nothing but a string object. Okay, so this returns false, because if you can check the logic inside equals method, here this object is checking here as an instance of with a string. If this object is not an instance of string, then it will skip this if block, and it will come here and it will return false, right? So that is what the output. Well, here you can see s1 dot equals s2. s2 is nothing but string buffer object, and in equals method here comes a string buffer object, and string buffer object is not an instance of string. That's why this if block will get skipped, and it will come here and it will return the false, right? That is what we can see the output. Okay, I hope you understood the code snippet and why equals method return the false over here, because equals method internally check whether the instance we have passed is instance of string or not. If it is not, then this condition fail, and then it will return false. Okay, great. It's a very important question, guys. Let's head over to next question. What will be the output of this program? Well, let me quickly copy this and paste it here. So it's pretty simple program. We have created two string objects using new keywords, s1 equal to new string java guides, s2 equal to new string java guides, right? And system.out.println s1 equal to s2. So look at here will be the confusion. s1 equal to s2, we are using assignment operator, and we are just assigning s2 to s1. It means s1 will be printed here. So let me run the program, and you can able to see the output java guides. Okay, we have just assigned s2 object to s1. Okay, just don't get confused with equal to operator over here. Okay, we are using assignment operator in this code snippet. That's why the output is java guides, right? Great. Let's head over to next interview question. What is the output of the following program? So let me again copy this code snippet, paste it here, and then we'll understand. Let me run the program first. Okay, it returned true. Well, let's understand the program now. String s1 equal to hello, s2 equal to new string hello. Well, this s1 object is created using string literal, s2 object is created using new keyword. Alright, and here you can see we are using intern method. Alright, so basically the use of intern method is it will move the object from heap memory to string constant pool. Well, let me write the comment over here. So whenever we create an object of the string using new keyword, it will store in a heap memory, right? Heap memory, and this object will be stored in a string constant pool because we have created a string object s1 using string literal. Well, what intern method do is it will move the object hello from heap memory to string constant pool, from heap to string constant pool. Alright, now s1 is pointing to hello string. Okay, so using intern method we have moved this hello object from heap memory to string constant pool. Alright, and then if you can see the content of s1 is also hello. Hello is already present in string constant pool, but here we are again storing the hello in the string constant pool by using intern method. But what JVM does is it will first check whether the same string is exist in string constant pool or not. Okay, if it is not exist, then only it will add. Otherwise what JVM does, it will return the reference. Okay, it will point this s2 to the hello and it will return s2. In this case s1 and s2 both are pointing to the same object, that is hello, in the string constant pool. Alright, and here we are using equal to operator to check whether both the references are pointing to the same object in a string constant pool or not. Well, in this case both objects are pointing, that's why the result should be true. Alright, I hope you understood what this program does. Alright, great. Let's head over to next question. How many objects will be created in the following code and where they will store in a memory? So this is pretty simple one. So when we create a string object using string literal, it should be stored in a string constant pool. Okay, and again we are creating a s2 string object using string literal, but look at the content over here. We are creating s2 object with the same content. So basically JVM will check whether the same content of the string is exist in the string constant pool or not. If it is not exist, then only it will store, otherwise it will point the reference and it will return that reference. In this case only one object will be created and stored in a string constant pool. Well, the next question is what is the output of this below code snippet? Well, here you can see s1 is a string object which is created using new keyword, and s2 is again a string object which is created using new keyword, right? And we have created both of these string objects using new keyword, so both of these objects should be stored in different memory location. That's why s1 and s2 have different references. And look at here, s1 equal to s2. So as we know that equal to operator is used to check the references, whether both the references are pointing to the same object or not, right? And when we create a string object using new keyword, it is stored in a heap memory, and in a heap memory both object occupies different memory location. That's why equal to operator returns false, because both objects have different memory locations, right? And the next question you can see it's opposite. Here we have created string objects using string literal s1 and s2. So in this case s1 and s2 both string objects are created using string literal. So when we create a string object using string literal, it will be stored in a string constant pool, right? And JVM will basically manages the string constant pool. So JVM will check whether Java guides string is already present in a string constant pool or not. If it is present, then it will simply point s2 to that object and it will return s2 object, s2 reference variable, right? In this case s1 and s2 both are pointing to the same object in the string constant pool. Okay, and here you can see s1 equal to s2. So this should return true because both s1 and s2 pointing to the same object in the string constant pool. Alright, So this code snippet prints output as a true because we have created both string objects using string literals, and both of them are part of string constant pool. That's why it printed true. Alright, so these are the few coding interview questions that you will get in written test or coding technical rounds. Okay, so just have a look into these Java string trick interview coding questions whenever you will prepare for the interviews. Hey there everyone, Ramesh here. In this video we are going to discuss the difference between list and set in Java. This is one of the frequently asked interview question, especially for beginners in Java interviews. So let's discuss the difference between list and set in Java with an example. Alright, list allows duplicate elements, whereas set does not allow duplicate elements. We can store a duplicate elements in a list, but when we try to store a duplicate elements in a set basically replaces the existing value. Okay, let me demonstrate this point with an example. In Eclipse I have created a program. So this program basically demonstrates like list allows duplicate elements. Okay, I have created a list object using ArrayList class, and I have added 3 elements to the list. So element 1 I have added twice, so element 1 is going to be a duplicate element in a list. Okay, and I have printed list here. So once I run this program, I should be able to see these 3 elements are printed in a console. Okay, so look at here, I can able to see element 1. So element 1 I have added twice to the list, and same element I can able to see in a console. It means that list allows to store duplicate elements. Okay, great. Now let's take a look at set. So this is the program to demonstrate set does not allow duplicate elements. So here I have created a set object using set, and I have added 3 elements, element 1, element 1, element 2 to the set, and element 1 is a duplicate element in a set. So once we run the program, we should be able to see only 2 elements to be printed on a console, because set does not allow duplicate elements, and whenever we try to insert duplicate elements it will replace the existing one, right? So let me run this program and let's see the output. Yeah, here we go. So here in a set we have added element 1 twice, but in a result we can see only 1 element. So basically element 1 is replaced. Okay, so this program demonstrates that set does not allow duplicate elements. Alright, I hope you understood this point. The next difference is list is an ordered collection. Okay, it is also called a sequence, and it maintains the insertion order. It means that whenever we display a list, it displays all the elements in a list in the same order that we have got inserted into a list. Okay, whereas set is an unordered collection, it does not maintain any order. Alright, so let me demonstrate this point with an example. So look at here, this is a list object we have created using ArrayList, and we have added few elements to the list. Okay, element 1, 2, 3, 4, 6, 5, 7, 9, 8. Alright, and we know that list is an ordered collection, it maintains the insertion order. So let me run this program and let us see how it displays the result. Yeah, so let's verify the result. Element 1, element 2, 3, 4, 6, 5, 7, 9, 8. 1, 2, 3, 4, 6, 5, 7, 9, 8. So this demonstrates that list is an ordered collection and it maintains the insertion order. It means, look at here the result. It displays all the elements in the same order that we have got inserted in the list. Okay, now let's take a look at set. So I have created a set object using set, and I have added few elements to the set, and look at here the elements, element 1, 2, 3, 4 and 6, and then I have added element 5. Okay, so after element 4 I have added element 6 and then element 5. Alright, so let's run the program and let's verify the result. Yeah, here we go. Element 1, element 2, element 3, element 4 and element 5, and then element 6. So look at here the order that I have inserted elements in a set. After element 4 I have inserted element 6, but you can see here it displays element 5. After element 4 it displays element 5. It means that the insertion order is not maintained in a set. Okay, so this program demonstrates that there is no insertion order maintained in a set. Okay, I hope you understood this point. So these are the two major difference between list and set. And look at here few more minor differences, like list interface has few implementations like ArrayList, LinkedList, vector and stack, and set interface has implementations like hashset, linked hashset, tree set, etc. Okay, and list allows any number of null values, whereas set can have only one null value at most. Let me demonstrate this with an example. So look at here, I have created a list using ArrayList and I have added 3 null values to the list. Okay, so as we have just seen that list allows any number of null values, right? So I have added 3 null values to the list. Now let's run the program and let's see the output. Yeah, here we go. So we have added 3 null values to the list and we have got 3 null values in our output. Now let's see how it works in case of set. So look at here, I have created a set object using hashset and I have added 3 null values to the set. So as we have just seen that set, it only allows only one null value at most. Okay, and I have tried to add 3 null values. Alright, let's run the program and let's see the output. Yeah, here we go. Okay, so whenever we try to add more number of null values, like I have added null value, first null value, second. So whenever I try to add second null value, then it will replace the existing one. Okay. Hey there everyone, Ramesh here, back again with another video on Java interview question. In this video we are going to discuss difference between ArrayList and LinkedList in Java. So this is one of the frequently asked interview question, especially for beginners in Java interviews. Let's go ahead and let's discuss the difference between ArrayList and LinkedList in Java. Well, before deep dive into the differences between ArrayList and LinkedList, let's quickly have a look into the overview of ArrayList class and LinkedList class in our Java collections framework hierarchy. So look at here, we have Java collections hierarchy, and at the top collection interface is a root interface, and we have a list, queue, set, dequeue and sorted set core interfaces in Java collections hierarchy. And on the other hand, we have also map interface and hash map, link hash map. So these are the implementation of map interface. And look at here, ArrayList class implements list interface. Alright, and LinkedList class implements list interface as well as dequeue interface. Okay, got the key here. ArrayList class implements list interface, but LinkedList class implements both list and dequeue interface. Hence, ArrayList is only used for list and LinkedList is used for list as well as queue. Okay, great. Now let's take a look at the differences between ArrayList and LinkedList. ArrayList internally uses dynamic array to store the elements. On the other hand, LinkedList internally uses doubly linked list to store the elements. Well, let me explain you with the diagram. So ArrayList internally uses an array, right? For example, consider we have array starts with index 0, and let's say we have 10 elements in ArrayList. So ArrayList internally uses array, and ArrayList start with index 0. Okay, and linked list internally uses doubly linked list to store the data. So basically doubly linked list is a data structure, and it is a collection of nodes, and each node consists of three parts. For example, let's say this is the node which is present in doubly linked list, and each node has three parts. So first part is the previous pointer to the node, okay, and this part is a next pointer to the next node in the collection, and this middle part contains a data. Okay, so these are the three parts in a node. Okay, got it? So linked list internally uses doubly linked list to store the data elements. So this is the difference. So next difference is manipulation with array list is slow because it internally uses an array. If any element is removed from the array, all the bits are shifted in a memory, whereas manipulation with a linked list is faster than array list because it uses doubly linked list, so no bit shifting is required in memory. Let me explain this point with a diagram. So look at here, array list internally uses array, right? So whenever if we remove an element in array list at a middle, then there are a lot of shifting required. Okay, let's say if we have 1 2 3 and up to 10 elements in an array, if we remove third element from the array list, then this should be shifted, right? This element should be shifted in this location, and again this element should be shifted here. So there are a lot of shifting required in a array. Okay, and array list internally uses arrays, so array list is a little bit slow for manipulation. Okay, and linked list internally uses doubly linked list, so there is no shifting required in a linked list. Alright, understood? Next difference is array list consumes a less memory than linked list, whereas linked list consumes a more memory than array list because it stores the next and previous references along with the data. For example, let me quickly draw a diagram here. Let's say this is an array, start with index 0, and let's say we have 10 elements in an array. So this is the array, array list. Array list internally uses array, right? And we have a linked list. So linked list internally uses doubly linked list, right? And doubly linked list contains a collection of nodes, and each node consists of three parts, and this part contains reference to the next node, and this part contains a pointer reference to the previous node, and this part contains the data. Well, in terms of memory usage, so linked list consumes a more memory than array list because linked list also stores a previous and next references along with the data in a collection. But in case of array list requires only memory to store an element along with its index. But in case of linked list requires a little bit more memory to store previous and next references. Okay, got the point? And next difference is array list class can act as a list only because it implements list interface, only list interface. On the other hand, linked list class can act as a list and queue both because it implements list and dequeue interfaces. Well, so look at here collections framework hierarchy. As we have mentioned earlier, like array list class only implements list interface. On the other hand, linked list class implements list and dequeue interfaces. So linked list can be used as a list as well as queue, but array list only used as a list. Alright, I hope you understood this point. So array list is better for storing and accessing data. Linked list is better for manipulating data. For example, so in case of array list, if you want to insert or remove elements at a middle, then array list performance wise it's a bit slower because there are a lot of shifting required. But in case of linked list, if you have insertion and removal operation at the middle of the collection, then linked list performs very good. Okay, so One more point I want to discuss, like when to use array list and when to use linked list. So whenever you want to perform insertion and removal operation at the middle of the collection, then highly suggested to use a linked list. Alright, so in other cases like in a retrieval operation, array list is much better than linked list. Alright, I hope you got this difference. Alright guys, these are the few differences between array list and linked list, and there are similarity between array list and linked list, like array list also contains duplicate elements and linked list also contains duplicate elements, and array list and linked list both maintains the insertion order, and array list and linked list both can contain null values. So these are the few similarities between array list and linked list. Alright guys, I hope you understood the difference between array list and linked list. So these are the few important points and differences, so that you guys can remember, and you guys can explain in interviews. Alright guys, I hope you understood the differences between array list and linked list. Now let's take a look at Java collections framework hierarchy. So first we have a collection. So collection is basically a root interface in Java collections framework hierarchy. And we have a list, queue and set. So these are the sub interfaces of collection interface. And list, queue, set. So these are the interfaces which extends a collection interface. And look at here. Here we have array list, linked list, vector and stack. So these are the concrete implementation of list interface. Alright, so these are the commonly used implementation of list interface. And here we have a set implementations like hasset and linked hasset. So these are the two commonly used implementation of set interface. And here we have sorted set interface. So this is the purpose of sorting the elements in ascending or descending order. So here we have tree set class which implements sorted set interface. And here we have queue interface. It has several implementations, like priority queue is the common implementation of queue interface. And here we have dequeue interface which extends queue interface. And here we have array dequeue implementation class which implements dequeue interface. So alright guys, these are the commonly used interfaces and their implementation classes. And we have map hierarchy. Let's take a look into the map hierarchy separately. So we have map interface. It contains key value pair, and there are many commonly used map implementation classes, like hash map is the most commonly used class which implements map interface. And we have linked hash map and hash table. So hash table is a legacy class in collections framework hierarchy. And we have sorted map. So the purpose of sorted map is to sort map keys and values. And we have tree map class which implements sorted map. So this is the commonly used map hierarchy guys. Now we theoretically understood the collections framework hierarchy. Now let's see how the collections framework hierarchy is implemented in actual core Java packages in action. Let's go to the Eclipse IDE, and we have created Java collections framework project in one of the previous video, and this is the GRE system library which is associated with this project, and expand GRE system library. And within a GRE system library you can find rt.jar file. So rt.jar file, it located inside a gre/lib folder. Alright, and rt.jar file contains all the core Java packages. And remember, Java collection interfaces and classes are located inside a java.util package. Let's go ahead and let's search for java.util package here. Yeah, here we go. So this is the java.util package. So look at here, inside java.util package you can see .class files. So in order to view the source code of .class files, you need to install decompiler in Eclipse IDE. So I have already installed decompiler in Eclipse IDE so that I can able to see the source code of .class files. So in order to install decompiler in Eclipse IDE, go to the help and go to the Eclipse market and just search for decompiler, and you can install decompiler and Eclipse IDE so that you can able to view the source code of .class files. Alright, great. Within a java.util package, let's search for collection interface. So collection interface is a root interface in Java collections framework hierarchy. Alright, and it internally extends iterable interface, which is for the purpose of iterating over a collection of objects. Alright, and collection interface has many child interfaces, right? So let's search for one of the child interface, that is list interface. So this is a list interface, and list interface extends a collection interface. Okay, so if you look at the collection framework hierarchy, list interface extends a collection interface, and we are looking this same hierarchy in action in actual source code of core Java packages here. List interface extends a collection interface, and list interface has several implementation classes. Right click on list interface and open type hierarchy. Here you can see different classes are implementing list interface. For example, ArrayList class. So ArrayList class extends abstract list, which implements all the common methods, and ArrayList class implements a list interface, and it also implements a different interfaces like serializable, clonable, random access, etc. Okay, and look at here, the default capacity of ArrayList is 10, and we'll learn more about ArrayList in further videos. And we have linked list class, which implements list interface, and linked list basically internally uses a doubly linked list for the implementation. Alright, and again we have different implementations like vector implements list interface, and we have also stack. Now this completes list interface and its classes. Now let's go for set interface. Let's search for set interface here. So this is the set interface, which internally extends a collection interface, and set interface has several implementation classes. Let's see what are the implementation classes. Right click and open type hierarchy. So look at here, hasSet is a class which implements set interface, and we have linked hasSet, which again implements set interface. So these are the common concrete classes which implements set interface. And sorted set is interface which extends set interface, and sorted set has an implementation class, that is tree set. So that we can see by right click on this interface and open type hierarchy, and here you can see a tree set. Okay, so tree set internally implements navigable set, and navigable set internally extends sorted set. Okay, great. Now let's search for queue interface. So look at here, queue interface internally extends collection interface, and queue interface has implementation classes. For example, let's search for its type. So look at here, dequeue interface extends a queue interface, and dequeue interface has several implementation classes like array dequeue, okay, and linked list. And queue interface has an implementation class like priority queue. Okay, so look at here, queue interface has an implementation class, that is priority queue, and dequeue interface extends queue interface, and array dequeue implements a dequeue interface. So this is the hierarchy. So we have seen the hierarchy of collection in an action in actual jar file. Let's also look at the map hierarchy in a source code. Now let's search for map interface in java.util package. So look at here, map interface, it stores key value pair and it does not extend collection interface. So look at here, here are different implementation classes like hash map, hash table. So these are the classes which implements a map interface, and we have a linked hash map which implements map interface. And look at here, sorted map, which is the purpose of sorting keys and values of map, and it has an implementation like tree map. So this is all about the map hierarchy in actual core Java packages, that is java.util package. In this video we'll discuss one more very important Java interview question, that is difference between collections and streams in Java. Well, as we know that streams are introduced in Java 8 and collections were introduced in 1.2. And in this video I am going to demonstrate each and every difference between collections and stream with an example. Alright, so that you will understand better. Let's go and let's take a look into the first difference. Collections are used to store and group the data elements in a particular data structure like list, set or map. Well, as we know that we use a collection to store and group the data elements, right? On the other hand, streams are used to perform some complex data processing operations like filtering, matching, mapping stored on the data such as arrays, collections or input-output resource. Well, we basically use streams to perform some operations like filtering, matching, mapping, and we create a stream from different sources like arrays, collections or input-output sources. Well, let me demonstrate this point with an example so that you will understand better. Well, here I have written a piece of code to demonstrate this difference. Here I have created a list object using ArrayList implementation class, and list is basically a collection, and we store basically data elements in the list, right? And on the other hand, you can see here stream. Well, first we have converted list into stream because we basically create a stream from the collection or array or any input-output resources. So in this example, we are creating a stream from the list, and then we are performing some filtering operations using filter method on this stream. Okay, so here basically we are filtering apple from the list. Okay, and then finally we are collecting the result. It means that streams are used to perform some operations like filtering, mapping, collecting the result, etc. Streams are not used to store the data elements. Okay, collections are used to store and group the data elements. On the other hand, streams are used to perform the operations like filtering, mapping, collecting the result. In this example, we are using filter method to filter apple element from the stream elements, and again we are using collect method to collect the result in a list. Okay, and then finally we have printed this list. Alright, so let me run the program and let me show you the output. And here you can see, here we have used stream to perform filtering operation. Okay, so filtering operation here basically we are filtering apple element from the stream. Okay, and here is the output, apple is filtered from this stream. Okay, so basically collections are used to store and group the data elements. On the other hand, streams are used to perform the operations like filtering, mapping, collecting the result, etc. Well, let's take a look into the next difference. You can add or remove elements from the collections. On the other hand, you cannot add or remove elements from the stream. Well, as we know that in collections we have add and remove methods, right? We can use them to add or remove the elements from the collections. On the other hand, you don't see any methods like to add the elements or remove the elements because we don't use stream to add or remove the elements. Okay, we use stream to perform some operation. For example, let's consider the same example over here. Here we have created a list object using ArrayList implementation class, and here we are using add and remove method. Okay, so basically ArrayList class provides add and remove method to add the element to the list and to remove the elements from the list. So this is how we can add and remove elements from the collection. On the other hand, you don't find any add or remove APIs or methods in a stream because we cannot add or remove elements from the stream. Okay, stream is used to only perform some operations like filtering, mapping, okay, matching and collecting the result, etc. Alright, guys, one more important to note here is that whenever we create a stream from the different resources like array, collections, input, output resources, and if we change the stream, then its source does not change. For example, here consider list is a source for a stream, because here we are creating a stream from the list, and whenever we do some operations like filtering, mapping and matching operations on stream, then list could not be modified. For example, let me print the stream over here. Before that, let me remove this statement, and here I will print the list. I will just use for each here, and then I will just print each element from the list, and here I'm going to use method reference. Okay, perfect. So what we have done, basically we have created a stream from the list and we have modified this stream. Okay, and whenever we modify stream by using filtering, matching, mapping, etc., then the source, that is list, should not be modified. For example, let me run the program and let me show you the output. Okay, so here what I will do, I will put one new line. Okay, let me run the program again. Yeah, there we go. You can see here the output. So result, so this is the output of the stream. Okay, and apple is filtered from this list, so you can see banana, mango, orange, and then fruits is the list, and I have printed fruits over here, and you can see fruits list contains 4 elements. Even though we have performed some stream operations, that is filtering on fruits, but the source, that is list, is not modified. It means that whenever we create a stream object from the different sources like arrays, collections, input, output resources, and perform some operations on stream, then the source should not be modified. In this case, the list is not modified because list is a source for the stream. Okay, so this one is the important point to note. Well, let's take a look into the next difference. Collections have to be treated externally using for loops. On the other hand, streams are iterated internally using for each loop. Well, as we know that we can iterate over collections like list, set, map using for loops, right? We can use for loop or for each loop. On the other hand, on the stream, we can use for each method. I mean, we don't have to use for loop to iterate over stream elements. Stream have its own iteration mechanism. For example, you can see here the code snippet. We have created a list and we are iterating over a list using for loop as well as for each loop. And you can see here the stream elements. I mean, stream provides its own internal iteration mechanism, and it exposes for each method, so we can use for each method of stream object to iterate over stream elements. Okay, and if I run this program, it should work properly. Okay, great. It means that collections have to be iterated externally. On the other hand, streams are iterated internally because stream provides internal iteration mechanism and we don't have to use loops to iterate over stream elements. On the other hand, collections we can iterate using for loops. Well, let's take a look into the next difference. Collections can be traversed multiple times. On the other hand, streams are traversable only once. It means that we can loop collections multiple times. On the other hand, we can loop streams only once. Okay, for example, so look at here the code snippet. Here we have created a list and we have added elements to the list, and we are iterating or we are looping this list multiple times. First by using for loop, second by using for each loop. It means that we can iterate collections multiple times. Okay, we can traverse collection multiple times. On the other hand, you can see here stream. So first we have created a list and we have converted a list into stream, and then we have performed some filtering operation, and then we have stored this filter method result into a stream because filter method returns a stream, and then we are traversing over a stream by using for each method. Okay, and if I want to traverse this stream again here by using for each loop, for each method, then this will basically gives the error. It means we can traverse stream only once. If we try to traverse it again, then it will give the error. Okay, for example, let me run this program and let me show you the output so that it will clear to you. And there we go. You can see here the error stream has already been operated upon or closed. It means that we can iterate or loop or traverse stream only once. And in case of collection, we can traverse collection multiple times. Okay. Well, let's take a look into the next difference. Collections are eagerly constructed. It means whenever we create a list, set or map, all the elements are computed at the beginning itself, right? On the other hand, streams are lazily constructed. It means that in a stream we have two types of operations, intermediate operations and terminal operations. And until and unless the terminal operations should called, the intermediate operations cannot be completed. For example, look at here, we have created a list and all the elements are computed at the beginning itself. Okay, this list is created eagerly. On the other hand, you can see a stream is created lazily. Okay, because here you can see based on the condition the stream is created. Alright, it means that collections are created eagerly. On the other hand, streams are created lazily. Alright, so these are the few notable differences between collections and stream. And I have explained each and every difference between collections and stream with an example, and I believe that you understood all these differences. In the interview, make sure that you will explain all these differences and try to give examples. Alright, great. In this video, we'll take a look into Java Stream API interview questions and answers. Well, in this video, we'll discuss some important and frequently asked Java 8 Stream API interview questions and answers. And as usual, we are going to see each interview questions with an example. Well, let's take a look into the first question, that is, what is stream or a stream API? Well, stream APIs are basically introduced in Java 8. And we can use stream API to process collection of objects. Well, typically we create a stream from different sources like collection or array or input-output resources, and we perform some operation on that stream elements. Alright, so basically a stream is a sequence of objects that supports various methods which can be pipelined to produce the desired result. Well, we can perform different operations on stream, and the operation can be a pipeline. For example, look at here the diagram. This diagram summarizes all about stream. Okay, for example, look at here, we can create a stream object from different sources, like you can create a stream object from an array, from collection, input output channel. Alright, once you create a stream object, then you can perform different operations, like you can perform intermediate operations on stream object, or you can perform terminal operations on stream object. Alright, so here you can see the intermediate operations like filtering, sorting, mapping, alright, converting one object into another object. So these are the intermediate operations, and these intermediate operations basically return a stream object so that you can perform the terminal operations on stream object. So terminal operations, you can see the aggregate operations like min, max, count, sum, collecting a collection result. So these are some terminal operations. Alright, so just remember or just memorize this diagram. This diagram summarizes all about stream. You can create a stream from different sources like an array or collection or input output channel, and you can perform intermediate operations and terminal operations on stream object. And intermediate operations, here you can see you can perform filtering operations, you can perform sorting, you can perform mapping. Alright, and you can perform terminal operations like you can count the stream elements, you can find the maximum, minimum. Alright, you can iterate the stream elements, and finally you can collect the result of the stream by using collect method. Alright, so there are a lot of APIs that are available, as a intermediate operations and terminal operations that we'll see in next upcoming interview questions. And stream does not store elements. Well, we can use a collection to store the elements, but stream does not store the elements. Alright, we use stream to perform some operation on the elements. We cannot store elements in a stream. Alright, because we create a stream from collection, right? And we need to perform some operation on stream. Stream is not, for storing the elements. Stream is functional in nature. It means whatever the operations that we perform on stream, it cannot modify its source. For example, let's say we create a stream from collection, alright, and whatever the operation that we perform on stream, it cannot change the collection, alright. So stream is a functional in nature. Alright, so this is all about stream. So just try to mention key points about stream to answer this question. Alright, great. Next question is explain stream operations. Well, again you can see this diagram over here. So stream basically has two types of methods, intermediate methods and terminal methods. So we use intermediate methods or operations to perform different operations like filtering, sorting, mapping. Alright, and these intermediate methods or operations returns again a stream object so that we can perform terminal methods on it. Alright, terminal operations on it. For example, you can see the terminal methods or terminal operations like we can count the stream elements, find the minimum, maximum, sum, alright, and finally we can collect the result of the stream. Alright, so these are the two types of operations or methods in a stream, intermediate and terminal. Alright, so here you can see stream operations are divided into intermediate and terminal operations. And intermediate operations transform a stream into another stream. For example, filtering, sorting, and mapping. For example, look at here the code snippet. Here basically we are using filter method, stream provided filter method to filter the stream elements. For example, this is the list of products. Alright, and we have added a few products to the list, and then here we are basically filtering the products based on the condition over here. So the product's price is equal to 30,000. So those products will be filtered from this stream. The intermediate methods like filter, map, so these methods basically returns the stream object so that we can chain other method calls. Like for example, look at here, filter method returns a stream object so that we can again call for each method on that stream object. So this is what we called as chaining the method calls or pipelining the method calls. Alright, so this is the example for intermediate operation. So you can also see few more examples, like here we are using map method as an intermediate operation. So map method basically map one object into another object. For example, look at here, this is the list of products and we are converting list of products into set of products by using map intermediate method. Alright, perfect. And this is about intermediate operations. So just remember, intermediate operations transform a stream into another stream. For example, filtering, sorting, mapping, etc. And on the other hand, a terminal operation that produces a result such as for each method, min, max, count, sum, okay, and a new collection. So these are the few terminal operations. For example, look at here for each method, right? So here we have a list, we have added a few elements to the list and we have converted list into stream, and then we are using for each method of stream to iterate over stream elements. Okay, and for each is nothing but a terminal operation. And again here another example, you can see min and max terminal methods. So here basically we are counting the maximum price of the product and minimum price of the products. Alright, just remember stream has two types of operations, intermediate operations and terminal operations, and try to provide examples for these operations, like what are the intermediate methods and what are the terminal methods, and try to write some code snippet in the interview if you have a pen and paper in your hand. And if you are sharing your screen, then try to type the code snippet in notepad or some ID and showcase to your interviewer so that interviewer will be impress for your answers. Well, let's head over to the next question. Next question is how to create a stream objects in Java, or what are the different ways to create a stream objects in Java. Well, I have mentioned here a couple of ways to create a stream object in Java. Well, first option is we can create a empty stream by using stream.empty method. And second way, you can see we can create a stream objects from different collections like collection, list, set. So these interfaces have a stream method, so we can use stream method to create a stream. For example, look at here collection.stream method. All right, so this will return a stream object, and you can see we can create a stream object from list by using stream method, and again we can create a stream object from set by using stream method. All right, so this is how we create a stream from different collections. And here another example, you can see we can create a stream object from array. So stream provides op method, okay, different overloaded op methods, so that we can use to create a stream object. And here look at here, op method takes array as an input, okay, a b c, okay, we are providing these elements separated by comma, isn't it? So this is what the array. All right, so we can use array as a source for this stream. And next way is we can create a stream object from string chars method. All right, so chars method basically returns an int stream. Okay, we can use chars method, string provided chars method, to create a stream object. All right, so these are the different ways we can use to create a stream object in Java. All right, we can also create a stream object from input, output, channels or resources as well. Well, let's take a look into the next question. What is the difference between collections API and stream API? Well, this is a very important interview question, guys. And here I have mentioned few notable differences between collections and streams. All right. So the very important difference between collections API and stream API is that collections are used to store and group the elements in a particular data structure like list, set, or map. All right, so we use collection to store and group the elements, whereas streams are used to perform complex data processing operations like filtering, matching, mapping, etc. All right, just remember, collections are used to store and group the elements. For example, we can use a list, set, or map to store the elements in a collections, right? On the other hand, we create a stream objects from the collection and we perform a complex data processing operations like filtering, matching, and mapping. Well, look at here the example. So this is a list collection we have used to store the data. All right, so basically we use collection to store or group the data elements, isn't it? And here we are using stream to perform different operations like filtering and collecting the result. All right, so just remember, collections are used to store and group the data elements, and on the other hand, streams are used to perform different operations like filtering, mapping, sorting, etc. Next difference we can see here, you can add to or remove elements from collections, but you cannot add to or remove elements from streams. For example, look at here. Here we have created a list object by using ArrayList class, and we have added a few elements to the list, and we have removed the element from the list. All right, this means that we can add or remove element from the collection. But in case of stream don't have such APIs or methods to add or remove the elements. Okay, just remember this important point, like collections allows to store and remove the elements. On the other hand, streams does not allow to add or remove the elements. Okay, great. Next difference we can see, the main specialty of Java stream is that you no need to worry about iteration while using streams, because streams internally provides a iteration mechanism by using for each method. Stream performs iteration internally behind the scenes for us. We don't have to use an external concept like iterator or for loop to iterate over streams. All right. On the other hand, you can do the iteration externally over collections using loops. For example, look at here the code snippet. Here we are using for loop to iterate over collections. It means that we can use for loop or for each loop or iterator to iterate over collections. Okay, it means that iteration is external to the collections. But on the other hand, stream have its own iteration mechanism. It internally provides a for each method to iterate over a stream of elements. We don't have to use a for loops to iterate over stream elements. Stream provides a for each method to iterate over stream elements. Okay, so this one is a notable difference between stream and collection. Well, the next difference is streams are traversable only once. If you traverse the stream once, it is said to be consumed. To traverse it again, you have to get a new stream from the source again. On the other hand, collections can be traversed multiple times. Well, once you traverse the streams, you cannot traverse it again, because you can see here the code snippet. We have created list object, and here we have converted list into stream by using stream method, and we have performed some filtering operation on stream, and then this filter method returns again the stream object over here. And here you can see here we have iterated over stream elements by using for each method. So this is nothing but we are traversing the stream elements by using for each method. And if you try to traverse or loop it again, you will get an error. Okay, you will get stream has already been operated upon or closed error. Okay, if you try to again traverse it, you will get the error. Okay, so it means that you can perform only one traversal operation on stream, but in case of collection you can traverse collection multiple times. Alright, so this one is the notable difference between collections and stream. Alright, just try to explain to the interviewer with these code snippet, guys. Well, let's take a look into the next question. What does the stream map function do? Why you use it? Well, probably you use a map function, right? Map function is very useful. If you want to convert one object into another object, then you can use a map method. Alright, so map method is an intermediate operation, and you can use a map method to perform map function operations in Java. It means you can transform one type of object into others by applying a function. Well, look at here the code snippet to understand more about map method. So this is the examples. Here we are basically converting a list of string objects into a list of integer objects. For example, you can see here we have created a list of string objects, and here we have converted a list of string objects into stream of string objects. Okay, and we are calling map method on stream. And look at here, the internally map method will convert each string object into integer object by using value of method. Well, integer is a wrapper class, it has a value of method, so this method will basically convert string into integer. And map method, it will take each element from the stream, and it will convert each string element from the stream into integer elements by using value of method. And then here we are using collect method to collect the result of this map operation. Alright, I hope you understood what is the use of map over here. So you can use map method or operation to convert one type of object into another type of the object. And map method takes a predicate interface as a method argument, and we can use a lambda expression to implement a predicate interface. And here we are basically using method reference to directly call the value of method. Instead of using method reference, you can also use a lambda expression. Alright, just remember what is a stream map method do and why you use it. Well, map function is basically intermediate operation in a stream, and we can use a map method to convert one object into another object. And this is the code snippet to demonstrate how to use map method. Okay, you can give this example, like you can convert a list of string into list of integers by using map method. Well, let's take a look into the next question. What does stream filter method do when you use it? Well, we frequently use filter method, right? If you are using Java 8 features, then probably you have already used filter method, right? So filter is one of the commonly used method, and you may get an interview question on filter method. All right, so Java stream provides filter method to filter stream elements on the basis of a given predicate. This method takes a predicate as an argument and returns a stream consisting of resulted elements. It means that we use a filter method to filter a stream elements based on some condition. For instance, you can see here the example. We have a list of string objects, and list basically contains the elements like Java, C, Python, and we want to filter this list of string elements. We want to just remove C from this list. Alright, so in order to do that, here look at here, we first convert list into stream, and then we call filter method on this stream. So look at here, filter method, we are calling filter method on a stream, and filter method is basically an intermediate operation, and it takes a predicate interface as a method argument, and we can use a lambda expression to implement a predicate interface, right? That is the reason here we are providing a lambda expression. What this lambda expression does is, it is just here doing some filtering operations, like we are just checking whether the stream element is not equal to the C string C. Okay, we are just removing this C string from the stream of elements by using filter method. Alright, finally we are collecting the result of this filter method by using collect method, and you can see the output of this program here, Java Python. We have filtered out the string C from the list of string objects. Okay, so this is how we use a filter method to filter the stream based on some condition. Well, let's take a look into the next question. What does the stream plat map function do? Why you need it? Well, we have already gone through the map function, right? And you're probably wondering, what is the use of flat map function? Well, flat map function, as name suggests, it is a combination of map and plat operation. This means you first apply the map function on the stream, and then you flatten the result. Well, in order to better understand about this function, let's take the example over here. You can see consider this is the structure, meaning it is a list of list. Okay, and we want to make this big list into a single level list. For example, look at here, we want to convert this big list of list into this single list. So in order to do that, we can use plat map function. So a plat map function, what it does, first it will do a map operation on this, and then it will flatten the result like this. For example, look at here the code snippet. We have created a list of even numbers 2, 4, 6, and then we have created another list for odd numbers, and we have created another list for prime numbers, and we want to store all these list objects into a stream by using op method. Okay, look at here, we are just passing these list objects to the op method. All right, and after that we are calling plat map method on this stream. And what this plat map method do, it will first apply the map operation, and then it will flatten the result into a single level. You can see the output of this program. So we have 3 lists, and we have stored these 3 lists into a stream, and we have used plat map method to flatten the result of stream into a single level. Single level meaning only one list. Okay, well, let's take a look into the next question. Difference between stream map method and stream plat map method. Well, we have already gone through map and plat map methods with example. So let's quickly summarize difference between these two methods over here. The function you pass to the map operation or map method returns a single value. On the other hand, the function you pass to the plat map operation or function returns a stream of value. And the next difference you can see, plat map function is a combination of map and plat operation. Map is used for transformation only, but plat map function is used for both transformation and platting. Okay, so this we have seen already with example. Alright, so these are the few notable differences between stream map function and plat map functions. Well, let's take a look into the next question. What is the difference between intermediate and terminal operations on stream? Well, intermediate stream operations return another stream, which means you can further call other methods of stream class to compose a pipeline. It means that the intermediate operations returns the other stream so that we can chain the method calls. Okay, for example, look at here, these are the few intermediate stream operations like filter, map, plat map, distinct, sorted, pick, limit, skip. So these are the intermediate stream operations, and you can see the example over here. This is the example to demonstrate the intermediate operation filter, map. Okay, so filter and map methods basically returns another stream object so that we can call other methods of stream class to compose a pipeline. For example, filter method returns a stream object so that we can call further a map method on that stream object, and map method is intermediate operation. It returns a stream object so that we can call a collect method on a stream object. In this way we can chain the method calls or we can compose the pipelines. Alright, great. So this is all about intermediate operations. So try to give the use of intermediate operations, and also mention these intermediate operations and also mention the example. Okay, on the other hand, stream terminal operation produces a result other than streams like value or a collection. For example, these are the terminal stream operations like any match, all match, non-match, collect, count, find any, find first, for each, min, max, reduce, to, array. So these are the terminal operations on stream, and you can see the example over here. Here we are using collect and for each terminal methods to perform terminal operations on a stream. Alright, just remember these stream APIs or methods. Okay, important methods like filter, map, plat map. Okay, and here you can see for each, min, max, okay, collect, count. So these are the few very important stream APIs or methods. You just remember, because you will get questions on these methods only. Alright, these are the top 9 interview questions I have listed over here, and these are the basically frequently asked interview questions on stream API in the interviews. In this video, we will take a look into few important and frequently asked interview questions on Java 8 features. Well, it doesn't matter whether you are a fresher or experienced candidate, you will definitely get a few questions on Java 8 features in the interview. Right? So in this video, what we're going to do is we're going to discuss few frequently asked Java 8 interview questions and we'll try to answer them. Well, I try to answer these Java 8 interview questions with examples so that it will be easy for you to understand. Well, let's take a look into first question, that is, what are the new features were added in Java 8? Well, here I have listed all the Java 8 features like lambda expressions, method references, optional class, functional interfaces, default and static methods, stream API, date and time API, Notion JavaScript engine. So these are the Java 8 features, and apart from these Java 8 features, we can see some of the improvements or enhancement made in a Java 8 release. For instance, collection API enhancement. So these are the few methods or enhancement were added in the collection API in a Java 8 release. For example, for each method in the iterable interface were added. Stream and parallel stream methods in the collection interfaces. Right? And apart from that, you can see other API or JDBC enhancement, compact profiles. Right? So you can just answer like you can name all the Java 8 features. Apart from that, in Java 8 release, some of the enhancements made for the existing APIs like collection API, JDBC API and other stuff. Right? Great. Next, let's take a look into the second question. What is lambda expression? Well, as you mention all the features, Java features, then immediately you will get a question like what is the lambda expression? Well, the lambda expression is simply a function without having any name. It can be used as a parameter in the function. So lambda expression facilitates functional programming and simplifies the development a lot. Well, the main use of lambda expression is to provide the implementation for functional interfaces. Let me demonstrate what is lambda expression and when to use lambda expression with an example so that it will be easy to remember it. Well, you can see the example over here. We have a printable functional interface, and this printable interface has only one method, that is print method, and it takes string as a method argument. And here in the main method, we are implementing the printable interface using anonymous class, and this is how we write a code to implement interface using anonymous class, right? And you can see using lambda expression we are implementing the interface, that is a functional interface. And look at the syntax over here, right? And you can see here lambda expression don't have name, it directly has the method argument, and this lambda expression is assigned to a reference variable, and this reference variable can be passed to other methods. Okay, so you can see here lambda expression is simply a function which don't have a name, and this lambda expression can be assigned to some reference variable, and this reference variable can be passed to other methods. Okay, and the main use of lambda expression to implement functional interface. So look at here, this is the functional interface. So functional interface is nothing but an interface. It has only one abstract method, right? And using lambda expression we can simplify a development lot. I mean, we can reduce a lot of code. For example, without lambda expression you can see the number of line of code here, right? So these number of lines of code we need to write without lambda expression, and with lambda expression only one line of code is enough. So whenever you have anonymous class which implements an interface with a single method, then always try to replace this anonymous class with a lambda expression. This will reduce a lot of code. Alright, so just remember these important points. And here is another example. So this example demonstrates that how the lambda expression can be passed as a method argument. So look at here, this is string function, again a functional interface which has only one abstract method. So in an interface by default the method is abstract, right? We don't have to manually specify abstract keyword to the method. And in a main method we are using lambda expression to implement a functional interface. And if you can see this function over here, print formatted, so this function takes a lambda expression as an implementation of functional interface. So look at here, print formatted method is called here, and the lambda expression implementation is passed here, right? So look at here, so lambda expression is assigned to some reference variable, and that reference variable again passed to this method as a method argument, and again this lambda expression is used here to just print the string. Okay, great. And one more example is we can pass a lambda expression as an argument to the constructor. So look at here we just implement the runnable functional interface using lambda expression, and that runnable interface again we pass it to thread class constructor. Alright, so these are the few important points you need to mention while answering this question. Okay, lambda expression is simply a function without having any name. It can be even used as a parameter in the function. Lambda expression facilitates functional programming and simplifies a lot. And main use of lambda expression is to implement the functional interfaces. Right, and if possible, try to mention these examples. If you have paper and pen in your hand in interview, then make sure that you will provide some code snippet to demonstrate what is the lambda expression and what are the uses of lambda expression and all those stuff. Okay, great. So let's head over to the next question. Why use lambda expression? Well, these are the 4 important points you need to mention. The first point is lambda expression and other Java 8 features like stream API, functional interfaces, So all these features facilitates functional programming. Lambda expression facilitates functional programming and simplifies the development lot. So if you can see the code snippet over here, without lambda expression we need to write this number of code, right? And with lambda expression in a single line of code we have done the job. So this will demonstrate that lambda expression simplifies, reduce the lot of code, isn't it? And the second use is to provide the implementation of Java 8 functional interface. So we have basically two options. Either we can use anonymous classes to implement functional interface, or lambda expression to implement functional interface. But lambda expression is more concise and it reduces a lot of code. So we use lambda expression to implement Java 8 functional interfaces. Next is a reduced line of code. So you can clearly see this example, how many line of number we have reduced over here. In a single line of code we have done a job of all these number of lines of code, right? So this is the third usage of lambda expression. And next is passing behavior to other methods. Well, lambda expressions enable you to encapsulate a single unit of behavior and pass it to the other code, for example to the methods or constructors. So you can see the code snippet over here. This is the functional interface, and here we are using lambda expression to implement this functional interface, and we are assigning this lambda expression to the reference variable, and we are passing this reference variable to the other method. Okay, other method is printed formatted method in this case, right? So lambda expression can be passed as a method argument. And also look at the code snippet over here. Lambda expression can be passed as a argument to the constructor. So here we have created a runnable implementation by using lambda expression, and then we are passing that lambda expression as a constructor to the constructor, that is third class constructor, right? So remember these four important points. Okay, whenever you will get a question like why use lambda expression or what is the use of lambda expression, then try to mention these few points. Okay, great. Well, the next question is explain lambda expression syntax. So this question can be asked for especially fresher. Just interviewer want to check your knowledge on the lambda expression, right? Whether you are familiar with syntax or not, right? So here you can see the syntax argument list. Okay, so argument list can be empty or non-empty, right? And second argument is the arrow token, or we can say arrow symbol. So it is used to link the argument list with body of the expression, right? And the third argument is body. So body contains expressions and statement for the lambda expression. So just remember these three components of lambda expression syntax. So first is argument list. Argument list can be empty or non-empty, and this is the arrow token or the symbol for lambda expression, and this will basically link a argument list with a body of the expression. And the third argument is body. It contains the expressions and statements for lambda expression. So once you know the syntax, you can also give some examples. Well, here you can see this is the simple functional interface. Addable, it contains a method add. It takes two parameters, int a comma int b, and we use lambda expression to implement functional interface, right? And look at here, this is the code snippet. And look at here the syntax. We are using exact syntax to implement the lambda expression. So this is the first argument, so it is the argument list, right? In our case, int a int b, and followed by the arrow token, and followed by the body. Body contains expression, right? So if you can compare with the syntax, argument list, and in the example this is the argument list. Argument list can be empty or cannot be empty, and then followed by second component is arrow token, and third is the expression, or body can contain the statements for lambda expressions, right? So this is how you can you can just give the syntax. Along with that, you need to also give the examples, right? So that interviewer will be happy with your answer. Okay, so this is how you can just answer to this question. Well, let's take a look into the next question. Next question is, what is the functional interface? So as you mentioned all the Java features, right? So next, immediately after lambda expression, you will get question like, what is functional interface? Well, functional interface is an interface that contains exactly one abstract method. It is called a functional interface. So whenever an interface contains only one abstract method, that interface is called functional interface. So it can have any number of default static methods but can contain only one abstract method. It can also declare the methods of the object class. Well, functional interface can contain any number of default or static methods but contains only one abstract method, right? So functional interface is also known as single abstract method interface because interface contains only one abstract method. That's why it is also called single abstract method. A functional interface can extend other interface only when it does not have any abstract method. And Java 8 provides a lot of predefined functional interfaces to deal with functional programming by lambda expression and method references. So for example, look at over here, printable is the functional interface, and as I mentioned, functional interface is an interface which contains exactly one abstract method, right? So here you can see printable is a functional interface, it contains only one abstract method. And here I haven't mentioned abstract keyword here. By default in interface, the methods are abstract, public and abstract, right? And here in a main method, we are using lambda expression to implement a printable functional interface. Correct? So just try to remember these points. Functional interface is an interface which exactly contains one abstract method, and functional interface can contains any number of default or static methods. So let me demonstrate this with an example in the IDE. So let's say I have interface that is printable, okay, and what I will do, I will simply say print method here, and this is string, okay, string str. So this is functional interface, and I can define any number of default methods over here. For example, default, let's say m1, default method should have implementation, right? Default, and then return type can be any void, int, etc. And I can also define the static method in the functional interface, something like void m2, right? So functional interface can contain any number of default methods as well as static methods, but it should contain only one abstract method. Alright, so let's go and let's implement this printable interface in the main method over here. Printable lambda printable, okay, and then in syntax here you can see the first argument is argument list, that is, let's say message, and followed by lambda expression arrow syntax, and then body, right? So in a body we can say, we can put the statement, and here I'm going to simply print the message. Isn't it pretty simple? So this is the message. Perfect. And then what I will do, I will simply call the print method, and I will pass the parameter something like hello world, something like that. And if I run this program, and we can able to see the result hello world in the console, right? So this is how we implement functional interface using lambda expression. Alright, so even though in functional interface we have defined default and static methods with only one abstract method, it should be able to work. Okay, this demonstrates that functional interface can have any number of default and static methods, but it should have only one abstract method. Perfect. I hope you understood about functional interface. Just try to mention the important points about functional interface and try to mention the examples as well. Next question is is it possible to define our own functional interface? Or this question can be asked in different way, like what is add functional interface and what are the rules to define the functional interface? Well, yes, we can define our own functional interface, because Java, it provides add functional interface annotation to mark an interface as a functional interface. And here you can see few of the rules that we need to keep in mind while creating the functional interface. The first rule is define the interface with only one abstract method. And second is we cannot define more than one abstract method. And third is use add functional interface annotation in the interface definition. And fourth is we can define any number of other methods like default methods or static methods. For example, let's take the same example over here, printable. So we can annotate this printable interface with add functional interface. So it means that whenever we annotate an interface with add functional interface, then this interface becomes a functional interface. And important rules like define an interface with only one abstract method. So here you can see we have defined only one abstract method. And second, we cannot define more than one abstract method, right? And third is use functional interface annotation. And fourth is we can define any number of default or static methods. Now this is a perfect example for functional interface, and this is the code snippet to implement a functional interface using lambda expression. If I run this program, it should work. Okay, great. And in one more important point over here is whenever an interface contains only one abstract method, then this interface is treated as a functional interface. You don't have to annotate this interface with add functional interface annotation over here. Okay, so you can also explicitly mention add functional interface annotation on top of this interface. This should also works perfectly, right? So just interviewer try to ask this question as well, like I have an interface with only one abstract method, and can I need to compulsory annotate this interface with add functional interface? So you should mention like no, you no need to add functional interface annotation if this interface contains only one abstract method, isn't it? It's not compulsory to add functional interface annotation on the interface which contains only one abstract method. If you know that this interface is a functional interface, then you don't need to mention add functional interface annotation. Let's take a look into the next question, that is name some of the functional interfaces in the standard library. Well, in Java 8 there are a lot of functional interfaces are introduced in java.util.function package, right? And here I have listed few of the commonly used functional interfaces like function, consumer, supplier, predicate, by function, binary operator, unary operator, runnable, callable, comparator, comparable. Well, these are the commonly used functional interfaces. But apart from these interfaces, you may find a lot of functional interfaces in java.util.function package. But try to mention as much as functional interfaces possible in the interview, right? And these are the commonly used functional interfaces I have listed over here. So you can just go ahead and check out these functional interfaces. And you may get a question on particular functional interface like what is functional interface and how we can implement functional interface by using lambda expression. Can you write the small piece of code for that? Or what is consumer interface? Can you write a small piece of code to implement consumer functional interface using lambda expression? So these are kind of questions you will get. So make sure that you will go through these important functional interfaces and try to use lambda expression to implement these functional interfaces. Okay, just have a hands-on experience on them, right? And if you want to know more about these interfaces with examples, then go ahead and check out these respective tutorials. Okay, in order to answer this question, just try to mention all these commonly used functional interfaces. Okay, great. Let's take a look into the next question. Next question is what is method reference? Well, method reference is used to refer a method of the functional interface. Well, it is a compact and easy form of lambda expression. Each time when you are using lambda expression to just referring a method, you can replace your lambda expression with a method reference. So here you can see the one example over here. So this is the lambda expression and it is just referring to method toString. So whenever you find this kind of lambda expression just to referring a method, you can simply replace this lambda expression with a method reference like this. And the syntax like this. Here you need to use a double colon. Okay, so this is the one example for method reference. So whenever you have a lambda expression to just referring a method, you can just replace your lambda expression with method reference. So let's take a look into the next question. What are different kinds of method references? So basically there are 4 kinds of method references. Here you can see the table. Okay, so reference to static method. So this is the example. You need to use a class name followed by double colon and then you need to call the static method. Okay, reference to instance method of a particular object. So you need to use object and then double colon and then you need to call object of that method. Third is reference to instance method of arbitrary object of a particular type. You need to use the arbitrary object of the particular type here and then followed by double colon and then call the method. And reference to a constructor. So you need to, whenever you have object creation and whenever you have a constructor call, then you can use this syntax, class name followed by double colon, that is method reference, and then new. These are the 4 kinds of method references. So if you get a question like what are the different kinds of method references, so then make sure that you will mention all of these 4 and try to give an example or the syntax for them. Okay, and if you want to learn more about different kinds of method references, then go ahead and check out my separate tutorial. Well, the next question is what is stream? How to create streams in Java? Well, stream is nothing but a sequence of objects from source such as collection, array, input output channel, etc. And stream basically supports aggregate operations. We use stream to filter, collect, print and convert from one data structure to another data structure, etc. And as we know that we use a collection and data structures to store the data, right? But stream does not store elements. It simply do some computational operations, right? For example, filtering, mapping, right, printing, converting from one data structure to another data structure. So these kind of computational operations we can do on stream, right? And stream is a functional in nature, so operations performed on stream do not modify its source. For example, let's say we create a stream from the collection. Collection is nothing but a source, right? And whatever the operations that we perform on stream, it cannot modify its source, that is collection. So here you can see a few of the examples to how to create a stream in Java. Well, we can create an empty stream and here is the code snippet. So we can use a empty method to create a empty stream. And here you can see this is the code snippet to create a stream from different collections. For example, collection, list, set. So this is the code snippet to create a stream from the collection. And this is the code snippet to create a stream from the list. Okay, we basically create the list and list provides a stream method. So we can use a stream method to create a stream for this list. And similarly, collection provides a stream method. So we can create a stream from the collection by using stream method. So similarly for set interface also provides stream method. So we can simply use stream method to create a stream from the set. Perfect. We can also create a stream from the arrays. So we can use array as a source for creating a stream. Okay, so this is the code snippet to create a stream from the source array. And here you can see this is the code snippet to create a stream object from the string using chars method. Alright, so these are the few examples that you need to take a note of it. So whenever you will get a question like what is stream and how to create a streams in Java, so you can just mention these few important points and also mention these few important examples. All right, so let's take a look into the next question, that is, what is difference between collection API and stream API? Well, collection API is available since Java 1.2 and stream API is introduced in Java 8, right? And collection API is used to store the data, but stream API is used to perform some computational operations, right? Like filtering, aggregation operation, mapping, converting from one data structure to another data structure, etc. Well, the next question is, what is optional in Java 8? Well, optional is nothing but a class. It provides a lot of utility methods to check the null values, and you can immediately get a question like, what are the advantages or what are the benefits using Java 8 optional class? You can mention these some of the advantages or benefits, like null checks are not required. If we use a Java 8 optional class, then null checks are not required. Well, in order to null check the object values, what we need to do is we need to add a if condition, or we need to call some utility methods to perform null checks, right? But if we use Java 8 optional, then we no need to check for null values. No more null pointer exception at a runtime. So we can avoid the null pointer exceptions at a runtime by using Java 8 optional class. And we can develop clean and neat APIs, because optional class provides a lot of APIs, utility methods that we can use to develop clean and neat APIs. No more boilerplate code. So we can reduce a few number of lines of code by using Java 8 optional, because it provides a method which implements lambda expression. So obviously we can reduce fewer lines of code by using Java 8 optional class. Well, try to mention these few points whenever you will get a question about Java 8 optional class. Well, the next question is, what is default method and when do we use default method? Well, default method is nothing but a method with an implementation, and we can define a default method in interface. And the main use of default method is to add a new functionality to the interface while maintaining backward compatibility with the classes that are already implementing that interface. Well, look at here the simple example. Vehicle is the interface. It contains two default methods, and default method contains the implementation. So usually when a new abstract method is added to the interface, then all the classes that implement that interface should implement that abstract method, right? So that is what the problem was. So whenever a new method is introduced in the interface, then the classes that are implementing that interface were breaking, right? Because we have to provide the implementation for the abstract method that is defined in the interface, right? That's why the default method is introduced. So default method can contain the implementation, and also it supports a backward compatibility with the classes that are already implementing that interface. Well, the best example is for each method in the collection interface, right? The collection interface does not have a for each method declaration. Thus, adding such a method would simply break the whole collections API. Therefore, Java 8 introduced the default method so that collection interface can have a default implementation of for each method without requiring the classes implementing this interface to implement the for each method. Right, so this is the best example. So whenever in an interview, if you get this question like what is the default method and when do you use default method, then make sure that you will provide some important points and also mention this example, right? Collection interface does not have for each method, and Java 8 introduced a default method so that collection interface can have a default implementation of the for each method without requiring classes implementing this interface to implement the for each method. So this is a very good example, guys. Okay, great. The next question is, what is static method? Why do we need a static methods in Java 8 interfaces? Well, as we know that static methods are utility methods or helper methods which is associated with a class or interface. It is not associated with any object, right? So basically static methods are class level methods, right? Not object level. And we need a static methods because of these few reasons. Like we can keep helper or utility methods specific to an interface in the same interface rather than in the separate utility class. So we no need to create a separate utility class to just keep few of the utility methods. So simply we can define that static methods in the interface itself. We do not need a separate utility class like collections, arrays, etc. to keep utility methods. We can simply keep in the interfaces. Clear separation of responsibilities. So we no need to keep all the static methods or the utility methods in the single class or single utility class. We can keep in the respective interfaces, right? So try to provide a few of the reasons why static method is introduced in Java 8. The next question is, how will you call a default method of interface in a class? Well, you might know that the super keyword, right? So you can use a super keyword along with the interface name. For example, look at here, the vehicle is the interface. It contains a default method with the implementation. And the question is, how you can call the default method from the class that is implementing vehicle interface. Well, here you can see, you can simply use a super keyword. Vehicle is the interface name followed by dot followed by super dot print. So this is the syntax to call the default method of the interface. So just remember this syntax. Next question is, how will you call a static method of the interface in the class? So as we know that in Java we can use a class name to call the static method, right? Similarly, you can use an interface name to call the static method. So here you can see vehicle is the interface, it has a static method. Car is the class which implements the vehicle interface. And in order to call the static method of the vehicle interface, here we just need to use interface name, that is vehicle dot blow horn, right? Pretty simple, guys. So these are the few important Java 8 interview questions that you have to check out before attending any Java interviews. In this video, we'll take a look into top 10 Java tricky coding interview questions. Well, these are the pretty interesting coding interview questions, guys, and do watch this video till end. I'm sure that you will get something out of this video. Alright, so these are the frequently asked Java tricky coding interview questions, guys, and you may get same question or similar kind of question in the interviews. In this video, we'll take a look into 10 coding interview questions. Alright, and yeah, so you may get this kind of questions in the coding technical round or written test. So basically you will get a code snippet and you need to trace the program and you need to tell the output. Okay, you need to explain the output. In written test, you will get a question like this. You will get a program or a code snippet, and then you will get a multiple choice questions. You need to select the correct option, right? So in this video, what I'm going to do is I'm going to execute piece of code in the IDE, and I will explain you the program and the output and all the stuff. Alright guys, without further ado, let's get started. Well, the first question is, consider the following program and predict the output. If we can observe this code snippet is related to object-oriented programming concept, that is polymorphism. Well, first let me copy this code snippet and let me quickly paste in the IDE. So I am using IntelliJ IDEA. Well, if you can closely observe this code snippet, this class, test class, has a print method, and print method is basically overloaded 3 times. Okay, first print method takes integer wrapper class as argument. Second, print method takes primitive type, that is int, as a method argument, and third, print method takes long as a method argument, right? So these are the 3 overloaded methods, right? And this is called a method overloading. And this code snippet is related to polymorphism, right? Polymorphism is an object-oriented concept, and in polymorphism we have 2 types, right? Compile type polymorphism is also called method overloading, and runtime polymorphism is also called method overriding. Well, this is the method overloading, right? In a main method, we have created object of test class, and we have just called the print method, and we have just passed the value 10. Now the question is, we have three overloaded print methods and which print method it will call, right? So basically you can see the method argument. So based on the method argument, it will call the print method. Well, in order to find the output of this code snippet, first you need to understand in which order JVM will match the method argument type, right? So let me write the comment over here. So this is the very important, guys. JVM matches first primitive int and then long and then wrapper integer class, and then we have int triple dot, that is called a variable arguments, right? Var args, right? So we have these four kinds of types, and JVM always looks for the int, the method which has a integer as a method argument, and next comes long, next comes integer wrapper class, next comes var args, that is variable arguments, right? So JVM will basically match the order in this way. It will first look for the method which has a primitive type int. Okay, now if you can execute the program, and you can able to see it will print the int as a output. So if you can see here, right? So always remember this order, and definitely you will get this kind of question, or I mean the same question or similar kind of question, right? And let's say if I commit this and if I run the program, then what will be the output? The output will be long. Look at here the order. If int is not specified, then JVM will match for long. So let me run the program, and if you can able to see long, right? I hope you understood, right? So just understand, I mean just try to remember this order. All right, let's go ahead and let's head over to the next question. Next question is, what is the output of the following program? Well, if you can closely observe this code snippet, it is related to string, right? So this question is related to string. Now what I'm going to do is I'm going to simply copy this code snippet and go to ID, and I will paste it here. Now let's understand this code snippet. Well, in string, basically we can create string object in two ways, right? First way is by using string literal, and second way is by using new keyword. And here you can see string s1 is created using string literal. So whenever we create a string object using string literal, which is stored in string constant pool. So what is string constant pool? Well, string constant pool is a special memory allocated in the heap area, and whatever the string objects we create using string literal, that objects will be stored in the string constant pool. And JVM will basically manages string constant pool for the string objects which are created by using string literal. Okay, next line of code you can see right here, s2 object is created using new keyword, and this object is stored in a heap memory. Okay, perfect. Now the important thing here is the intern method. All right, what intern method does? Well, intern method basically it will copy the object, that is s2, from heap memory into string constant pool. Now if you can see, s2 object is stored in heap memory, right? And explicitly we can copy this object hello from heap memory to string constant pool using intern method. All right, great. Now you can see s2 object is now stored in string constant pool, but the important thing here is hello. So hello object is already there in a string constant pool, and again intern method here, it is just copying the same hello content from heap memory to string constant pool. But what JVM does, it will basically check whether the same content, I mean the same value is exist in the string constant pool or not. If it is already exist, then it will simply point this reference to that object, and it will simply return that reference. It won't store again the same content of the value in the string constant pool. Okay, that is the important point, guys. And now s1 and s2 both are pointing to the same object, same content, that is hello, right? And here we are using equal to operator. So basically we use equal to operator to check the address comparison or the memory location. Well, in this case s1 and s2 both reference variables are pointing to the same memory location which contains hello value. That's why this will print true. Let me run the program, and there we go, output is true because s1 and s2 both reference variables are pointing to the object hello, right? And here intern method basically copy the object from heap memory to string constant full, and if this hello is already exist in the string constant full, that's why s2 is again pointing to the hello. If let's say if I change the content from hello to hello1 and if I try to execute this, it will print false because s1 is pointing to hello, s2 is pointing to hello1. So look at here, the content is different, right? Even though both objects are stored in string constant pool, but the content is different. That's why s1 is pointing to hello, s2 is pointing to hello1. That's why equal to operator returns false. If both the objects are, both the reference variables are pointing to the same object, then only it returns true. Alright, I hope you understood this code snippet and why we get output true. Let's head over to the next question now. Next question is, what will be the output of the following program? Well, if you can see this code snippet, again this code snippet is related to OOPS concept, okay, inheritance. Well, let me quickly copy this code snippet and let me paste it in the ID, and then we'll try to understand the code. Well, we have a base class with a constructor, and within a constructor we have just written system.out.println, and we are just printing base string. Next we have a derived class which extends a base class, and derived class has a derived constructor which just prints a derived string. And then we have one more class, derived, which extends a derived class, okay, and again it has a constructor which just prints derived string. Now we have a test class, public test class, which has a main method, and here we have just created object of derived with a parent class reference derived. Now the question is, whenever this object is created, what will be the output? Well, as we know that whenever we create an object by using class, then its constructor will get called, right? Now we can see we are creating an object of derived, alright, and it will call this constructor, right? So you might be wondering, it will just print derived, right? But it will print basically a base, derived and derived. Well, let me run the program and let me show you the output. So look at here. So this statement printed base and then derived and derived. So why it is printed these three lines of statements? Well, why it is printed base, derived, derived, right? So let me explain you guys. Well, probably you know about the super keyword, right? So basically super keyword we can use to call the parent constructor. And if you can see here, derived class extends derived, and in the constructor, if we don't specify super here, right, if we don't specify super, then compiler will basically automatically provide a super to call the parent class constructor, right? So let me quickly remove this, and again let's say compiler internally provides super to call the parent constructor. Now the controller comes here, and again this class has a constructor, and this class extends base. So derived is a subclass of base superclass. So again compiler will provide a super, and it will again call the parent constructor, that is base. That's why it will first print base and then derived and derived. So let me go ahead and let me put the debug points here, and let me run this program in the debug mode so that you will understand clearly. So look at here, first the control comes in this class derived because we are creating object of this class. Now it will come inside the constructor, and then by default compiler provides super statement here, and it will call the parent constructor. So let me quickly go to the next step, and look at here, it will comes to the derived, right? And again it will come to base. Let me go ahead and and then it will print the base. Let me provide a breakpoint over here, and there we go, it will print the base, and then it will come to again derived. There we go, and it will come to derived, right? That's why the output is base, derived, and derived. I hope you understood the flow, right? So if I give here super statement, it will call the parent class constructor, isn't it? Now again I will provide super statement here, it will again call the super class constructor. Now this program also gives the same result, right? So let me run the program, and if you can see the output, base, derived, derived, right? If we don't provide super statement, then compiler will internally provide a super statement to call the parent constructor. I hope you understood this code snippet, and this kind of question you will definitely get in the coding interview round or the written test. And this is one of the oops concept related questions, so try to understand this code snippet, and you may get same question or similar kind of question, right? Try to understand the concept and the flow so that you will be able to answer this kind of question. All right, great. Let's head over to the next question now. Next question is, consider the following program. Well, if you can see the program here, this program is similar to the previous program that we have seen. So this one, right? So this program is related to method overloading, and this program is also related to method overloading, right? So let me quickly copy this code snippet and head over to the IntelliJ IDEA. Let me paste it here. Now let me rename this test over here. All right, so look at here the code snippet. So this code snippet is related to method overloading, and in one of the previous code snippet I have explained this kind of program, right? And now you can able to guess the output of this code snippet, isn't it? So look at here, test method has 4 method overloaded methods, that is poo method. First poo method takes integer, wrapper class integer as a method argument. Second takes short, third takes long, and int args. Well, I have already told you, like JVM checks, matches the order in this way. First it will look for integer. If it is not there, then it will look for long, and if it is not there, then it will look for wrapper integer class, and then it will look for var args, right? In this code snippet you can able to see that int primitive type is not present in one of the overloaded method. Next comes long, so it will print the long, right? Poo long. So let me run the program, and if you can see, able to see the output, poo long, right? So int is not present in any of the overloaded method. That's why JVM will look for other type, that is long, and if it is present, then it will print. If we comment out this, then if we run the program, it will next look for wrapper integer, right? So look at here, poo integer, and then if we comment out this, now let me run the program, and it will look for var args. So look at here the order, and then if we comment this, then definitely it will print this one, right? So I hope you understood the order in which the JVM will match the types of the method arguments. So this is pretty interesting question, guys. I hope You understood? Just remember this order, you can able to answer this kind of questions easily. Okay, let's go ahead and let's head over to the next question. Next question is look at the following code and choose the right option. Well, if you can see the code snippet, it's pretty interesting and it is related to access modifier concept. So shape class has a protected method display, and we have a circle class which extends shape parent class, and we need to guess the access modifier here, right? And we have four options like only protected can be used, public and protected both can be used, public, protected and private can be used, only public can be used. Well, let me quickly copy this code and let me paste it here so that you can able to understand more. Let me remove this public, because in Java file we should have only one public class, right? I have already test class. Perfect. Now you need to guess the access modifier of the child class. Well, in the parent class or the super class, we have a method display which has the access modifier protected, and whenever we override this method in the subclass or the child class, the access modifier should be a less restrictive or the same access modifier. For example, here I can use a protected. Okay, this is supportable and this should work, and I can use the public. Okay, so this also works. If I use private, it doesn't work. Okay, so it is more restrictive, right? So whenever you override the method in the subclass or the child class, make sure that the access modifier of the method should be less restrictive or same access modifier. In this case, we should provide protected or public, isn't it? I hope you understood. So this question especially asked for beginners, just to check your knowledge on access modifiers. All right, great. Let's head over to the next question, and here you need to choose option B. Public and protected both can be used, right? Well, the next question is consider the following program. Well, again, if you can see the code snippet, this is related to OOPS concept. All right, so let me copy this code snippet and let me go to the IntelliJ idea. Let me paste it here, and if you can see here, we are using again the polymorphism concept over here. Okay, basically the runtime polymorphism. You can see base class, it has two methods, one is poo and another is bar, and in a derived class we just extend the base class and overriding the poo method and the bar method, isn't it? And in a main method we are creating the object of derived class with a parent class as a reference variable, that is base class, and we are calling the method poo method and bar method. So the question is, which poo method and bar method will get invoked? We have poo and bar method in both the classes, right? Base class and derived class, right? So this is the main the key, right? We need to guess which poo method and bar method will get called. So this is basically called upcasting. So here we are creating the object of derived class, but we are using parent class as a reference variable. And whenever you create object of the child class using parent class as a reference variable, then the child class or the subclass method should be called first, because this is the runtime polymorphism. Okay, so at a runtime JVM will invoke the subclass or parent class method. So in this case, derived class is a subclass and base class is a parent class or a parent class, right? So if you can run the program, and if you can able to see, it will print derived poo and derived bar. Let's say I have another method bar1 and bar1. Now you can guess, let me call the bar1 here. Now as we know that this is a runtime polymorphism, so it will first look for bar1 method in the subclass, right? So bar1 method is not there, then it will call the parent bar1 method. So if I can run the program, and you can able to see the output as poo bar1. So bar1 is not there in the subclass. That's why it went for child class, parent class method. If I override this method in the again derived class, and if I say this one is derived instead of base class, so if I run the program, it should print in derived bar1. Okay, so this is the runtime polymorphism. So whenever we create an object of the child class using parent class as a reference variable, then it should first call the subclass methods. Alright, I hope you understood this code snippet. Let's head over to the next question. Consider the following program and predict the output. Well, this is the multi-threading related code snippet, right? And this is pretty interesting question, guys. So let me copy this code snippet first and let me paste it in the ID. Let's understand the code snippet now. So we have my thread which extends thread class and overrides the run method, and it simply prints this statement. And then we have a thread test method, and within that we have main method, and we have just created a thread object, and we have called a run method on the thread object, and we have just printed one statement here. Now interviewer will ask you what is the output, and explain the code snippet. Well, if you have a knowledge in multi-threading, then you can able to easily understand this code snippet. Right here is the key. You can see here we are calling explicitly the run method over here, but ideally whenever we create a thread, we should start the thread by using start method. So thread provides a start method, right? And whenever we invoke start method, right, so start method internally invoke the run method, right? And here in the code snippet they are explicitly invoking run method. So this is the problem. So this, whenever we call the run method explicitly, this behaves as a normal method execution. It won't execute the thread, it won't start the thread in a separate thread. So this thread will run as a normal method. Okay, and if you call the start method, then only it will start the thread and it will execute in a separate path. Alright, I hope you understood the code snippet. Interviewer will basically check your knowledge on the threading, right? So ideally we call a start method to start the thread. We don't call run method, and start method internally call the run method, right? So this is the main problem here. You need to call the start method here, but here we are calling run method. So whenever we call the run method explicitly, so this will behave like a regular method call. Alright, great. So let's head over to the next question. Consider the following program and choose the correct option from the list of options. Well, again we have a base class, base 1 class extends base class, base 2 class extend base, right? And base class has a test method. Base 1 override the test method and provide the implementation, and again in a base 2 class overridden the test method and provided the statement. And here you can see in a main method we have created base 1 object, but we are trying to cast with a base 2 class, right? So this is not supported in Java, right? So this is a downcasting, isn't it? We have created an object of base 1 and we are simply casting base 2. We are simply making a cast with base 2 class here, but this is the downcasting, so it won't be supported in Java. So you need to select the option as a D. The program will result in exception, that is class cast exception. Okay, so this is pretty simple one, you might already know that. Next question is, consider the following program. Well, this is pretty straightforward and simple code snippet, and it is again related to string handling. So let me quickly copy this code snippet and let me paste it in the ID, and let me explain the output. Well, if you look at the code snippet over here, string s1 equal to hello. Well, here we have created a string object using string literal. So whenever we create a string object using string literal, that string object will be stored in a string constant full. Well, I'm going to write a comment over here, string constant full. And here we have created an object of the string using new keyword, and this object will be stored in a heap memory. Okay, and again here s3 object we have created using string literal, so this will be stored in a string constant full. Okay, great. Now here, look at here, if condition s1 equal to s2. So before understanding this, we need to understand the difference between equal to operator and equals method. Okay, so equal to operator, basically it checks whether these two objects are, reference variables are pointing to the same object or not. Okay, so basically equal to operator is used to check the address location or the memory location, whether s1 and s2 both are pointing to the same memory location or not. All right, so in this case s1 equal to s2, so both are pointing to different location, because s1 is created using string literal, which is there in string constant full. s2 is created using new keyword and it is there in a heap memory. So both are in different location, so both are pointed to a different location. That's why you can see the output is s1 and s2 not equal. Okay, let me run the program and look at here, s1 and s2 not equal, because s1 is pointing to the string object, that is hello, which is there in a string constant pool, and s2 object which is created using new keyword, which is present in a heap memory. So both objects have different memory location. That's why both objects are pointing to different memory location. Okay, so equal to operator is used to check whether the objects are pointing to the same memory location or not. Right, and look at here, second if condition s1 equal to s3. Well, s1 object is created using string literal and it is stored in a string constant pool. Similarly, s3 object is created using string literal and it is stored in a string constant pool. Well, basically JVM manages the string constant pool. Okay, so what JVM does, it will first check whether this hello object is stored in a string constant pool or not. If it is already present, then JVM will basically return the reference of that object. It means that JVM won't store two similar objects with similar content in the string constant pool. Alright, so look at the second condition over here, s1 equal to s3. So s1 object is created using string literal and which is stored in a string constant pool. s3 object is also created using string literal and which is again stored in a string constant pool. Well, basically string constant pool is managed by JVM. So JVM basically, it will check whether the string is present in string constant pool or not. Alright, if it is present, then JVM simply returns the reference, that is s3. Well, s1 is already stored in a string constant pool and s3 is again storing the same content, that is hello, in the string constant pool. But JVM will already check that hello is already present, right? That's why JVM, what it will do, it will just point this s3 to the hello. It won't store hello string again in the string constant pool. Only one occurrence of this object is kept inside string constant pool. Alright, it means that s1 and s3 both are pointing to the hello. And here we are using equal to operator to check the reference variables, both are equal or both are pointing to the same object or not. So in this case s1 and s3 are pointing to the same object, That's why you can see S1 and S3 are equal. Okay, here is the output. S1 and S3 are equal. Right. Now let us see one more very important thing here is S1 equals to S2. Well, here look at here we are using equals method. Okay, let me use equals method over here also. Equals S3. Alright, so let me run the program first. And there we go. So look at here, we have created three string objects, right? S1 equal to hello, S2 equal to new string hello, S3 equal to string. Well, all of these three string objects have the same content like hello, hello, hello. And if you can see the output, S1 and S2 equals, S1 and S3 equals. It means that equals method basically check the content of two objects. Well, here S1 equal to hello, S2 equal to new string hello. So hello, hello, it means the content is same, right? So equals basically checks whether both objects have the same content or not. If both objects have same content, then it will return the true, and then it will execute the if block. Otherwise it will execute else block. Correct? So let me just change this one. Okay, hello 1. Let me run the program. And look at here. S1 is not equal to S2. Okay, the content is different. That's why it is no went in a else block and is just printed S1 and S2 not equal. And again S1, S3. So content are different, right? That's why it went in a else block and it is printed S1 and S3 not equal. Okay, so in case of equals method, the memory location doesn't matter, right? The content matters. If content of both objects are same, then equals method returns true. Okay, so in Java, whenever you want to compare two string objects, then always use equals method. All right, great. So this kind of coding question you will get in interviews, and just try to understand the difference between equal to operator and equals method, so that whenever you will get this kind of questions, you will definitely answer it. Well, the next question is consider the following program and predicate the output. Well, this is the code snippet again related to string. So let me quickly copy this code snippet and let me head over to the IntelliJ IDEA and let me explain you the code snippet. And before understanding this, let me run the program and let's see the output first. Here we go. So basically what we are doing here is we have created object of the string using new keyword, and we have passed 5 as a string object. After that we have added a system.out.println, and then this is the value, right? So 1 plus 10. So one important thing is whenever this expression get evaluated, then it always goes from left to right. Okay, so in this case 1 is a operand, 10 is a operand, s is object, 1 is a operand. Okay, 10 is also operand. So this is basically called a operand. Okay, and here 1 and 10, so both are integer operands, right? That's why these two operands will get added. Okay, added means addition. 1 plus 10, 11. So you can look at here 11. After that we have a string object. It contains 5, and then 5 is concatenated with 11. Okay, and now it becomes 11 5. Okay, still 5 is a string, so it will again concatenate with 1. It becomes 1 1 5 1, and again string is concatenated with 1, so it will again concatenate with 10. It becomes 1 1 5 1 1 0. All right, I hope you understood the result of this expression. Okay, so it is evaluated from left to right, and whenever you will get a string in the expression, that will be concatenated. Okay, great. Alright guys, these are the 10 tricky Java coding interview questions that you have been asked in many interviews. And even I also taken many interviews, guys, and I have asked this kind of questions to the candidate. So go ahead and check out this blog post. So I have basically written a blog post on this topic and published on my blog, and I will provide a link of this blog in the video description below, so that you will take this blog post for your reference.